Hi everyone, thanks for joining subscribing this course. This is 300-535 Service Provider Automation course. In this course, we are going to learn about service provider automation technology. You can see the breakups here, 4 portions. One is starting with network programmability foundation, and then section 2, 3, 4, they are divided 30%, 30%, 30%. They have that weightage. So what I have done that I have created sections, subsections videos. You have to follow those videos. You have to complete section 1, 2, 3, and 4. Once you complete all these sections, you will be very good understanding service provider automation. Means you are ready to go for the automation. You can do the automation related to your service provider infrastructure. All right, so please continue this course. I hope that you will learn new technology, new things from this particular course. In section 1, we have to understand about network programmability foundation. You can see here the overall weightage is 10%. And let me show you the detail about that syllabus. We have to understand basics of Git, first of all, then the APIs, the different type of APIs, Python scripting, and more about Python. Okay, so what I have done, I have done the break of this section. First of all, we'll go and understand the Git related topics. So for that, I have created 4 videos. You can see introduction to Git Lab using GNS3, Git Lab, and Git Architecture and GitHub. So please go complete these 4 videos after this session, this video, and then we are very much completing subsection 1.1. Now the Git and GitHub, we are going to learn and we are going to actually copy the code more and more. We're going to search the different type of codes, whatever published by different programmer coders or network engineers, and then we can utilize those codes inside our lab environment, or you can again utilize inside the production environment. Now how it is going to work, and here you can see the graphic. We have the cartoon that, oh, is it how it is working? Now actually no idea. We have no idea about that, how it is working. And even we're not worried about how it is working. Only thing we are going to do that, we follow some steps, and once you follow the step, we'll see that we have some steps to follow to create the code, to upload the code, to merge the libraries and all. Correct? So we'll go and follow that. Again, if you get errors, save your work elsewhere, delete the project and download a fresh copy. That's the way that the network engineers are working when they have the programming related projects. Okay, so what are the things we can do it? And here you have the list. So made a change to code, realized it was a mistake and wanted to revert back. These are actually the problem with the application engineers or the programmers, that you have done something, you have some wrong syntax or code or some logic, you want to change it. Last code or had a backup with that old code, so you have the backup. Do have multiple versions of the code, uh, you have the difference in the code, or maybe some was working with some of the program and the new code having new program, you want to merge it, you want to take the difference, you have multiple copies, you have the backup. All these points are listed here, and the answer is that your zit will do that. So it's a public repository, not only the public, but here you can see that you may have 2 type of copies, so developer private and developer public. So one code that you publish for public use, and you want that different users or different programmers, they can copy those codes and they can utilize it to just check the authenticity or just check the scalability and the nature of the program, and they can improve it as well. Correct? So it's a shared code, and you can see that private is also So one copy with you and some portion or maybe some other code you want to share, you can do it, correct? So again, the final conclusion for all these steps that we are going to study is this slide. You can go and have a reference to this particular slide, and you can check the link as well from where you can get all this information. All right, so let's focus more on this Zit. Under the hood, how it is working. You may have multiple copies, you may have multiple versions. You can go and upgrade or degrade. We'll see that more and more in the upcoming session. How we can do the configuration. Obviously, in our lab, I have one GNS. I have my network automation tool. I will show that how we can do it. We can go and do the zit config, global username and the email address. Then my zit is prepared. I can go and initialize the project. Initially, it will be hidden under the zit directory. Now here you can see the flow. You have working directory. You can do the staging, and then you have the repository. We can go and follow these commands. Zit add dot. That means you can add the zit. Then you want to commit it. You can do the commit. So commit -m initial commit. We'll do the commit. Again, there are chances that for a certain program, multiple programmers are working at multiple locations. You can think this as a branch as well. So you have multiple branch. All the branches are independent, and in future you want to merge them. So first of all, there is a concept of branch, correct? So zit branch name. Say for example, branch is testing. You can commit with a new, and then you have the checkout as a masters. The master is very straightforward. Now in future, if you want to merge different type of branches, you can go and merge it. So you have your independent. First of all, you can go and create the repository. So you can add your username password, you can upload your project, you can do the commit. Then multiple projects working as different location or branches that you can go and merge. Again, if you want to share your changes, so you can go and do the push origin master and even the branches as well. These are the operations we are going to do. Obviously, we'll understand more and more. Now, this particular slide is important because this also we are going to use it or utilize it. So in future, some public code is there running up and running in the zit. We can go and we can copy to the local directory. Even you can go and create publish, someone can copy, or you can also copy the others code. Then once it is in your automation tool in your GNS, then you can do certain edits, you can do certain changes, and you can run your own program in your lab environment. Or once it is up running, you have validated in lab environment, you can go and run in the production environment as well. Okay, so these are the basic theories related to Zit. Obviously, more we work, more we are going to learn. So let's log into the Zit and do all the steps, follow all the steps that we have seen in this session. Before we'll start the lab, I just wanted to show you my setup here. Now we can go and install the GNS. You can go to this link, download the GNS. Everything is free. You can create your free account and you can use it. Now GNS is running over the server, over the VM. So you need hypervisor. Most of the hypervisors are free if you are doing the home lab. So for example, I'm using a VMware Workstation Pro. On that, I'm installing GNS3 VM. Although what I have done that I have created complete video that how you can go and install GNS3 over the system. So you can refer that video. But anyways, most of the engineers know that how you can utilize GNS3. Now GNS3 is also becoming very popular and it's very enhanced at this point of time. So if you go and check GNS version 2.2.10.11 now we have, so let me show you that what version I have, but this is 2 to 10. 11 is also present at this point of recording, and in future you'll see that more and more innovations inside GNS. Anyways, once you go and install the GNS, your GNS3, your laptop, you can see, means I have done some adjustment, although you will get in the right hand side of the pane where you can check all these information. So we are very much interested looking for the informations related to our devices, our networking devices. Now, when you go and do this thing, means when you go and add the devices, so for example, I have added SD-WAN edge device, I have added network automation, I have added CSR, ASA, etc. And as and when required, we can go and add more and more devices. So for that, what you need to do, create click template. So here you can see the plus sign, click next, and then you can go and search automation. Once your automation will come, just click install, and it will ask you next, and it will be finished. Because I'm already having this, so it is showing an error, but I can have actually multiples as well. So I can go and create, say, 02 and done. So now you can see that I have automation 1 and 2 that I can use it. Simply click drag and drop. Once you click drag and drop, you can see here you have your automation engine. Behind the scene is this Ubuntu machine. And then I want to build my small network. So I can go and use GNS switch. Recommended that you can use this GNS switch because this is very lightweight. Okay. Then I can go and use this NAT because I want to give the IP address, NATed IP address to my automation tool. And that's very much done. Now, suppose if you want to interact with your laptop, then you can go and use this cloud and then done. Now, once we have this very basic lab setup running, we can use these connectors. We can connect. So let me go and use this connection, say here, and then again we can go and use the connection like this and like this. Now in future lab, you will see that we can go and change the design layout, those things as well. Design layout, that means simply you can change the symbol as well, and in future you will see that I have changed as well in the upcoming videos. At the moment it's okay. Now once you have the network automation tool and you want to provide the IP via the DHCP, so you can go and click edit config, and you want this automated IP, so you can remove those extra symbols. And now if you go and start, it will become green. Double click, you have your automation engine. Now the font size is very small at this point of time, so you can go click settings. Once you're inside the setting, you have the general tab where you have the putty. Launch the putty, go to the appearance, make this font size that you can work with. So for example, I made this 16 or maybe 18. Once it is there, then you should go to the logging, and not logging, but you can go to the sessions and you can click default session and save it. Correct? I can click save it, and then I can click close. And now if I go ahead, let me restart this session, but you can see that it got one IP address. If you go and double click here, you can see the font size will get increased. Correct? Now this is the initial basic setup that it is working behind the scene, but what we can do that I have certain codes that we should run once we have the first install. So apt-get install, once my automation engine will come, actually it is trying to connected with these links and trying to getting some of the patches or some of the updates. because this is GNS 2.2.10. In the older version, you have to do it manually. Even when it is doing connecting with the remote servers and updating the downloads or updating the patch, you should go and use these steps as well. So here you can see in the back that apt-get update, Python 3, Python 3 pip, netmiko, napalm, simple JSON. And then below you can see that we have this apt-get install git and then the virtual environment. So even you can copy paste, or if you want to type it, you can do update. It will take some time to do the update. Meanwhile, let me show you what is behind the scene. This is actually a very important page that we have. So here you can see that in bottom, line number 38, zit clone HTTP. So I'm cloning the configuration or cloning the program from the zit, and then I'm going to this particular folder, and then I'm going to the virtual environment that I will cover in upcoming session, and I can run my code, correct? So that's actually very important to run the code. Now here you can see that it has some problem getting the connection with the internet. So once you run your system, you do ping to the public IP, and here you can see this is unreachable. It should reach. Now sometimes it happens that some of the laptop you need to restart your VMware in GNS3 after the installation. So what I will do, that after this session I will reboot my laptop and I'll come back in the next upcoming session where we have to follow the zit test step, correct? So I will reboot my laptop, I'll come back, I will copy paste all these configurations. Simply you can do like this, just copy and paste, and you can put here. So I can go here and put, and it will run all the lines of configuration one by one. So my Python will be ready, netmiko and napalm, these things you will come to know in the upcoming Python session. Then the zit will be up and running, and at this point of time I don't want to enable or create my virtual environment. That first of all we'll learn about the theory, and then we'll do that. Obviously in upcoming session we have so many codes to understand and learn, so slowly we'll learn all these skills. All right, so let's just stop here. Let me go and reboot my laptop. I'll come back with the same setting and we'll proceed further with zit related steps. Now we have to perform lab related to Git, and for that better that we can see the lab. First of all, I have created the lab over GNS that we have already discussed, and then I have certain packages to install. Even that packages you can also install. So I have packages related to Python, related to pip, related to napalm, netmiko. Most of the things I'll cover in upcoming sessions. And then we should go and do this apt-get install git. Now once we have this git installed, obviously we can go and run the commands related to git. So here you can see that it is already installed. Then whatever we have studied earlier, I can go and do the configuration like that. So for example, global, and then say username. I can go and give my name, and then again I can go and give the email as well. So user email is networkers.com, and then rest of the command, if I have any say directory, say p1 is my directory name for example, and then I can go and create certain files, say nano p1 text, any name. I can go and save this. I can copy this p1 text to my p1. We can move to p1, I can go and check, okay, I have P1 text. Now I want to do the initialization. So once I am in the P1, I can go and use git init, and then I want to add. Again, these are the commands which are fixed, and while doing the practice, you'll come to know that what is the use of that. Again, we can create some sort of notes, a notepad, and then we can use those codes. Finally, let's do the commit, and then I can do the initial commit, correct? So initial commit, and here you can see initial commit has been done. Now if I go and check here, you can see that we have .git p1. This is the way that we can go and do the commit. Now next, we have a study about the branch as well. So I can go and create a branch. Name is p2, and then branch is say p2 text. Likewise, we can go and continue, correct? And now we have the commit for the new working tree is clean, no branch master, because we don't have the master. But yeah, we can go and continue our configurations like that. So we are already in master, and then if we want to create the branches, so we can go and create the branches. So for example, the branch. Now here you can see that parent is not known, so that's why this is throwing an error. But yeah, this is the way that we can go and do the commit. We can add it, we can create the branches. Even in future, if you want to merge, we can use the merge command as well, as we have discussed earlier in the slides. All right, so let's stop here, and next session we'll go and check 1.2, where we have to learn, understand about the APIs. At this point of time, we should understand the Git architecture and the GitHub. Now Git or Zit that you're seeing here in the slide here, we have four major components. We have working directory, local repo, and the remote. Now this remote repo can be GitHub, and we'll see that what's the official definition of GitHub. But it is something like your web browsing repository. You can go and create your account over a GitHub. As long as you're public, you can use the resources. But if you want your private repository, you have to pay something. Companies, they may have their private, they may have their public repository, correct? Now this portion here, that is the working directory, staging area, local repo, that we have done the lab as well. So you can go and use the keyword git add commit. Once you do the commit, it will go and write to the repo. So here you can see that we have the staging area, we have the local repository, and then if you want to communicate with the remote repo, so that option is also there. So from local repo, you can go and do the zip push. If you want to get some update, you can go and use zip fetch. Again, we have the checkout and the merge option, correct? Let's understand more about this. Now, here you can see the summary of the slides that we have, or summary of the steps that we have already followed. So we have a step. You are in the initialize step, update, change, and diff. Now again, you can see that workspace, local repo, and remote repo, and how and what are the commands to do the communication with. This direction is that you're getting the information from the repo, and this direction is that you're sending the information from local to the remote repository. All right, so now let me go and explain you that what is the remote repository. Although there are few popular, but we are using mostly the GitHub, and you can go and create your account over GitHub. This is the web-based type of repository that you can go and use. So here you can see that we have the GitHub. This is the distribution version control system based on Git that is web-based. It's free as long as you have the public repository. But if you want to go and use the private one, you have to pay some fees for that. How we can go and log into this? Let me show you that how we can go and log in. Let me clear the slide one. All right, so here you can see that we can go and utilize the command here, git clone. Although I have one example here, you can see that git clone https github AI devnet, from where I want to copy certain codes and want to utilize in my program. So if I go to my automation tool, where we have installed the Git and all the related packages that we can go and communicate with Git, I can go and create the clone, and best we can do the copy paste, but let me type here and then the AI devnet and then say getting started with Cisco SD WAN. And obviously this is actually a good place where you can check the Python REST API integration. Okay, so now here you can see that it's unable to resolve. Let me see if I can ping. Okay, so my network is down at the moment, but yeah, you can go and utilize this command. In future we have so many labs and where I'll show that how you can go and use this command, and you can create your local repo. Means you can copy from the remote end to your local system. You can do the changes and then you can run execute the programs. All right, so let's stop here. In 1.2 and 1.3, we have to understand about the characteristic of API style, REST and RPC, and then understanding API synchronous and asynchronously. I have created 4 videos: understanding of API detail, understanding of REST API, gRPC, that will cover 1.2. And then for 1.3, I have created one separate video to understand the synchronous versus asynchronous API. So please go complete these 4 videos, and they are very much completing our sections, subsections 1.2 and 1.3. Now, before understanding the REST and the other API methods that we have, the question here is that what is API? Now, the answer for that will be long. So let me start from here. That we know that as a network engineer, we have started as a CLI, means we are doing the coding with CLI. Now, when we are talking about CLI, the simple funda is that CLI is human. So we are the humans. We are interacting with the machine, correct? So this was something like human to machine interaction. Now again, we have the GUI. Just to make things simple, we can go and do the point click. So we have the GUI. Most of the appliances now, they have the GUI as well. Even the complex CLI, it's very difficult to memorize. It's error prone, etc. So we have the GUI where those CLI commands are preloaded. In other terms, we can think like that also. And then again, behind the scene, it is calling CLI, and then it is going and running over the screen or running over the machine, correct? But API is the game changer. Why? Because API is machine to machine language. So this is something like machine can understand to one machine to other machine. Now think like this. When we are talking about CLI can't be user for other machine. Means CLI is giving the, while the CLI we are giving the instruction. But one API can be user to other API, or one API can feed the other API, etc. Okay, so that's a big difference we have, and that's the fascinating thing happening in the industry at the moment, that everyone is looking towards API. So here you can see that API is a way that a machine can talk to machine, and it's really fast. We are the only users with respect to CLI, but now in terms of API, machines are communicating to each other, and there are n number of example. One of the example is, suppose if you are looking for the best hotels or list of the hotels nearby your area, so your hotel programming can go and query Google, and then Google will go and give the result, and behind the scene everything is working in terms of API. So as a user, I triggered one API in my mobile. One API means, again you will think that the HTTP web browsing. In loose term, you can think that is also a type of API, because in HTTP we have several methods like get method. So whenever you're seeing anything, or whenever you're doing any query, that will go via get method. So HTTP get, give me these results. That's the get. Equivalent to CLI is the show commands. That is also get method. Even SNMP is also using SNMP get methods. So get method is something like you are doing the query, you want some result. So now here you can see that one API can trigger other API, and it is endless and seamless. So n number of API can trigger n number of API, and then some correlation program is running behind the scene, and then it will give the result. Correct? And that's again the in high term, that is the machine learning and other stuffs. So APIs are the engine of innovation, and that's true. Now, is it difficult to learn API? Is it scary? The answer is no. It's not difficult to learn API, because if you know how to do the web browsing, you can play around with the APIs. The four popular method for REST, and REST is a one type of API. That full form is representational state transfer, which is using get, post, put, delete. Now this thing I'm going to cover more and more in the next recording. So separate 9 to 10 minutes for REST, where we'll learn, understand a little bit deep inside how the REST is working. But in a nutshell, it is something like we are doing the web browsing, and if we want to see something, we can use the get method. Again, you think everything is an object. If you want to update the object, you can go and do the put method. If you want to create a new object, you have to use post. If you want to delete an object, you have to use delete. Correct? So these are the methods we have inside the REST, because it's very simple. So that's why REST is quite a popular. Now again, there is common mistake, or there is confusion around that. Okay, then what is the use of XML? What is the use of JSON? Those things you will understand in upcoming session. So you have data model, you have encoding, you have transport, you have protocol. These are again a suite of protocol. These are again the stack that we should understand at which level what is there. So network layer, so for example, if you correlate with the TCP IP layer, so network layer functionality is different with respect to data link layer, or transport layer, or session layer, etc. So all the layers, they have their own function. Correct? Likewise, the XML and JSON, they are working as encoding methods. Then there is transport. So for example, SSH can be transport, maybe SSL, TLS, those can be transport. So there is other transport method. There is again data model like Yang. So that is again in a different level, etc. So we should understand in the protocol stack where they are residing, and then how they are working. Correct? All right. Now again, when we are talking about the REST method, and this particular example is very important, and that's why I have taken this. So here you can see that you have the different portions. So first portion here is the server or host name. Then what resource you are looking for. So you are looking for API for Zio code. The encoding is JSON, means the output will come in JSON format, and then the parameter. So you have one, the second, and the third request, and this is one of the API example. Again, what I am going to do, that next two videos you'll find related to REST and gRPC. So we will understand more about these APIs, because in future we have to do the Python programming for these APIs as well. Let us learn REST. REST is a representational state transfer. What it is doing, and there is some misconception that this is very difficult to learn and understand. But behind the scene, what it is doing is that simply that how we are accessing or surfing the web browsers, the same way, the same method the REST is doing. So in the diagram, you can see that when we are retrieving any website, we are sending the GET request and then we are getting the page, HTML page. Now, same way, we can use the protocol REST. We can send the request as a GET, means we want to retrieve it. We'll see that what methods or what verbs we have. So we want to read or retrieve the information, and then we'll get the information either in JSON or XML format. That's how easy is this, correct? Now more hands-on lab will do, more and more we'll understand about that. So I am planning to show you the lab in the next session, that how you can do the lab from scratch. Alright, so REST is the method that is going to use various type of verb or methods. What methods that it is going to do, I'll show in the next session. But it's very much similar that how we are accessing the web browsers. Again, remember that we have the encoding in form of JSON and XML. What methods we have? We have this CRUD method. CRUD is nothing but create, retrieve, or read, update, and delete. So actually the methods that we have is the get method that you want to retrieve or get some information, is put method that you want to uh, update an object. You have post that you want to create new object, and finally you have delete, that means you want to delete the object, correct? So these are the methods that we have being used, and these are the top methods, means the widely used methods that we are going to use inside the CRUD. So CRUD is nothing but the methods or verbs inside the REST. This is a stateless client server model. That's true. Again, we'll see in the upcoming slides. Developed by W3C, proposed by Roe Fielding in 2000, and nowadays it is widely used. Even if you want to do the automation in terms of configuring, monitoring, uh, other stuffs like certificate management, um, creation of object, deletion of object, in all those things are possible with the REST API. Obviously, you need to encode or you need to embed this method with some other method. So for example, I'm using Python to take these REST API objects or data, and then I'm converting with Python language in my table format. So I'll show you this lab in the upcoming session. Same way you can also use, and how you can use it I'll show you. So we have the CRUD method, we have the create, retrieve, or read, update, and delete. And here you can see that's interesting diagram, and it's very important diagram. So when you're creating, you are sending the payload. Let me go back. And that's very important, because you want to send some data, you want to create new object. When you're retrieving or reading, the success code is 200. This 200 is nothing but your code method. So you're retrieving the information, you're sending query, and then you're getting some payload information. correct? Finally, if you want to update, you're updating with the payload. Finally, if you want to delete, you can go and give the reference and you can delete it. So delete is the easiest operation. Then you have the get operation, then you have the put, and finally the post. In post, obviously, we should be very careful while creating an object. There are chances that you can create the same type of object, so that you can use certain other keywords that the objects will not uh, collide. Or suppose if same object is there, if you are not using the force command, that means it will not get created because already you have the existing object. So those things should be taken care. This CRUD method we have, and we can do all sort of thing related to get, post, put, delete, and we have the patch as well. But mostly you will see that we are using get, post, put, and delete. These four methods will serve all the purpose that we have. Okay, so get, that means you're retrieving the data, post means you're creating new object, put means you're updating the object, and again here you can see patch means update and modify. So slight difference in between put and patch. Put will update and replace a resource. Patch, again the name suggests patch, will update and modify the resource. Now what methods we have and what type of output will come into the picture, again we'll see in the next slide when we have the lab section. So once you go and do the REST API call, you will get these information. So first of all, you have the HTTP verb, means what you want. You want to get the information, so you can use the get method. Then you should go and use the full URL. I will show you that how it look like. Then there is some optional thing that body, if you are making certain changes, this is optional in what format you want the output. Again, if it is a post method, so we have the method plus the payload, and if it is a get method, we are doing the request and we are getting the output plus payload, correct? So you will find that you have the header, you have the key values that will be there, but we will look for the data field, and these data fields that we can go and convert with Python language in some readable format, correct? So again, you have the content type, you have the acceptance. You can go and run the API. I will show you again what are the tools available we have. So here you can see that we have the curl method, which is a very popular tool. We can go and use the web-based method, that's the postman. But the thing that I want to use is the Python language. Python language, so because Python can interact with a number of devices, because now we have so many plugins, we have so many inbuilt programs as well, and we have so many resource code in the GitHub as well that we can go and utilize. Obviously, we can go to the Postman and we can do the query. I will show you in the next slide. All this information I'm going to share in the next slide. So before ending this recording, I just wanted to tell you that if still if you are in the Windows machine and if you have your PowerShell, so you can go to the shell. Once you are in the shell, here you can see the font size is very small. If I can go and increase the font and make this 24. All right, so now once you're here and you want to check this curl method, it's very easy. You can go and use the curl, and there are so many options we have with curl that you can go and explore. So I'm doing curl google.com, and then you can see that we are getting the result 200 is okay, that means success. You're getting the content related to Google page. Here you can see that the get request related to Google we are getting with the curl method. Okay, so let's stop here, and in next section I'm going to show you the Python integration with the API. Next protocol, we have gRPC, Google RPC. This is the functional subset of Netconf run over HTTPS. It has high performance. It provides simple client development. And here you can see the protocol stack. Now, already we have discussed this, that we have the data model, we have the transport, we have the encoding, and then the protocol. Correct? So here you can see the encoding is JSON CLI, the transport is HTTP, data model is Yang. And now next, if we go and check that what type of methods that it has, so here you can see that the method that we have is, obviously we know that we have get, put, post, and delete. Likewise, here you can see that we have different type of methods. We have the get conf, merge conf, delete, replace, get operation, so retrieve the operational data, CLI config, merge the configuration data in CLI format, and finally so CMD text output. Okay, so likewise other protocols that we have, this is also will be used, and this is high performance. Again, the functional subset of netconf, and the protocol format also we have seen. All right, so let's stop here. Now we reach to 1.3, and let us understand that the challenges encounters with asynchronous and synchronous API. What does it mean? What can it do for us, and what are the use cases related to synchronous and the asynchronous APIs? So let's understand, and which one obviously we are using. Synchronous. Now in this type of API call, what is happening, that it will wait until the API will get execute. That means that these APIs are working one to one. Now you can think this, that this is working in a manner of queue. So one call is coming and it will wait until it get completed. So then the next call will get started. Correct? Rather than asynchronous can have multiple calls. So at a time, multiple calls can happen. Now there may be pros and cons for both asymmetric and asynchronous and synchronous. That suppose if you have any error in the call API, if you have heavy load on a system, network bandwidth related issues, etc., and you can't run multiple APIs at a time. So you can think in both ways. There is plus and there is minus for both the calls. Now, few of the programs like Java, C, C Sharp, they are using synchronous method. On other hand, JavaScript, they are using uh, asynchronous method, and actually the asynchronous method is the common de facto nowadays. In our API calls, we are using asynchronous API calls. Now what is happening in this case is that suppose if you have multiple runs and if you have error, correct? So you should know how you are going to handle that error. So we can go and try and we can catch the error and then we can publish the result, correct? Now this particular slide that you're seeing here at this point of time, I'm taken from Cisco. What Cisco is telling is that synchronous API calls are blocking calls that do not return until either the change has been completed or there has been error. That's the key here. I'm telling that if we have the error, and suppose if we are doing the call that is asynchronous, it's not synchronous, because anyway synchronous has to wait till the execution will happen. So suppose if I have 10 API calls that is going on, and if I don't have error handling mechanism, all 10, there are chances all 10 can throw an error, and that is not good. Correct? So we should handle the error inside the asynchronous call. Now for asynchronous call, the response to the API call is returned immediately within a polling URL. You can just think like asynchronous calls are just, we are surfing the websites. You are entering some URLs, you are getting the result. Correct? Now again, in heavier load condition, it can be more efficient to submit multiple calls, async calls, and periodically check the result. Okay, so the key here is that, okay, we understand the synchronous and asynchronous calls, correct? Key here is that how we are going to handle the error if it is there. Now here you can see that the program, and I have given you the link as well, reference from where I have taken this. So asynchronous thing, here you can see in the diagram, it's quite clear. So you have API calls 1, 2, 3, and 4, and here you can see that you have the recovery as well. You have recovery as well. So what exactly this is? This is something like try and catch. You're trying something, you're catching the exceptions, and then the result is coming. So simply, suppose if you don't have exception rules in Java, it's quite popular that we have the exceptions rule or we have the exception handling. Suppose if you don't have the exception rule handling rules, then simply the program will exit from that block. So that block will run and it will come out. Even it will not go down and check the other options. So, but if you know that what type of errors or what type of exceptions you have, so block code execution, say for example, block 1 will happen, 2 will happen, 3 will happen, 4 will happen, and whatever try methods you have, it will go and try for those many blocks, and then it will exit out if they are not able to find the error. If suppose if block number 3 up to this, so this is error, this is error, but block 3 is ready to go, the code will execute from here and then again further onwards, correct? So that's the power we have with error handling. When we are doing such type of async calls, we should have the proper error handling mechanism configured. Great, we have reached to 1.4 where we have to learn about the Python script containing the data structure, the class, function conditions, loop, etc. So what I have done, that this particular section, that is 1.4, I have divided into two separate videos. So this particular section has follow up two sessions, two videos, where you will learn, understand about first of all basic structure of Python, and then the data types as well. So please go and complete two videos after this session, and then the section 1.4 will get completed. We'll meet in section 1.5 then. Let us understand Python. We know that the importance of Python language, and nowadays it is used everywhere. So either it's a networking or machine learning or artificial intelligence, you will find that the use of Python is huge. Why it is this much popular? First of all, this is the interpreter level language. The codes are easy to learn. Again, if you compare with the traditional programming, so for example, C, C++, Java, and then if you go and compare the Python, you'll find the result inside Python is very fast because it's almost like interpreter. Means you are doing the inline type of coding. You are giving input and you are getting the output. So not only that we can do the inline type of programming, but we can go and create a well documented program, and then we can run this as a script as well. So options are there in Python, and it's very lightweight, it's fast to execute, and it's widely used inside different type of operating system. So for example, in our case, you'll find that most of the Linux operating system by default, they have this Python running inside the box, or even it's very easy to install the Python language. You will see that I will go and install the Python. There is 3-4 commands that you want to do that for the installation. In Nexus OS, Python is there. You can go to Nexus OS, you can write Python, and you will move to the Python cell or Python interpreter. Alright, so here you can see that you can go to the Linux and you can type Python and you are inside the Python. So what does it mean that once you are inside the Python? So here you can see that I have my network automation tool, but Before going there, I want to show you that you should use these commands. I think the first two, apt-get update and apt-get install, to do the installation for the Python language. So I can go here and do the installation because already we have Python up and running. So it will not run much. Even if some minor updates are there, it will go and do the update. Otherwise, we are running Python. That's the latest version. Correct. So you can see that you can go and copy paste all these commands, and you'll see that your Python and then the integrated modules are up and running. So once Python is getting installed in the Linux machine, you can go and type Python. Here you can see that we are in the Python cell. Once we are there, at this point of time, we can assign the uh, values and then say y equal to x plus 4 and then say print y. You can see that how easy it is to operate. But in upcoming session, you will see that we have big scripts related to networking, device SSH and configuration, and open and close a file and run these scripts in different type of for or while conditions. Okay, so those things we'll see in the upcoming session. Now let's come back to the Python. So it's very easy to use and it's something like common to most of the networking devices. So that's why one Python can do the automation for most of the networking devices, and not only the networking devices, but there are other use cases as well in other technologies as well. So what are the benefits we have? It's a free and open source developed, portable, easy to use, learn, object oriented and functional, named after Monty Python. Cons is that it's not a program that is written in hex or binaries. That means it is not written in low level code. So that's why it's compared to low level program, it is taking much time to do the execution. Now again, if you go and compare with Tcl, Perl, PHP, C, C++, C hash, all those things, you'll find that Python is a winner because it's easy to learn and execute as well. Now to run this program, Python program, we have n number of options. One option that we are seeing here, that will be the best one, that I can go to the Python and then I can write the script. This is the inline way, but I can go here. Say for example, let me go out from here and then I can create a file, say test.py. That's the Python extension. And then you can go and write your script here, whatever script you have, and then it will get executed. So at the moment I don't have any. Let me show you if I have any other script up and running. So I have say nano, and let me show you this if I have any old script that I just wanted to show you. So here you can see that I have few of the scripts that is already up and already there, that I can show you the format and syntax. But at this point of time, I just wanted to show you that the extension is .py and it's very easy to build, and again it's very easy to execute as well. So I can go here to Python 3 because we are focusing on Python 3, and then I can run say wlc1.py. If I press enter, then this program will get executed and then we'll get the result. Although how I write this program, you will see that its complexity is there that you will learn in upcoming session. Okay, so it's easy to use and easy to execute, and there are several IDEs and all. So here you can see that you have IDE, you have Komodo, Python Win, PyCharm, etc. There are so many. What is IDE? What is integrated development environment? That you have one notepad type of say editor where you can edit the program and then you can run it. So I have one ID here, and by the end of this session, this video, I'll tell you that from where you can go and get it. So first of all, here you can see that I have my cell. It is looking like this. Again, if I go and put x equal to 10 and print x, so here you can see that how it is working. And then again, if you have any script, you can go and open, not like this. You can go and say create new file, and once you have this new file, this is your ID. Both are the ID. And then again, you can go and assign say x equal to 55 and print say x, and then you should save this. So if I go and save this as a say 55.py, once I save it, then I have option to run this. So I can go here on top, run, say run the module, and then we'll get the output here. Okay. So various ways to write the program. The best option we have that we should use the Linux, and then in GNS obviously we have the automation option that we can use. We can use that, and again we can connect with various networking devices. Now here is some level term about Python, so how the task is executed. So first of all, we'll go and save the program as .py extension. Then it is going to convert it into bytecode, that is the PYC, that's the internal conversion. And then we have the runtime PVM. So it's something like from high level to low level how the program is getting executed behind the scene. And here you can see this runtime is nothing but the Python virtual machine PVM. And again, with compared to C and other languages, you'll find it's easy to use, and it's using some sort of bytecode method to execute and run the program. The installation is very easy. Either you can go and use the Linux that we are using in the GNS3, or you can go to the link here, that is the python.org. You can download the version related to Windows or Mac OS, etc. Although in Mac OS you'll find this Python is already there. Even in most of the Linux system nowadays, Python will be there. Windows, you can go download the software, install, and I have shown you the IDE as well. But once you install that, then you can check that as well. Say we can go and run the uh, Python program in Windows. So this is showing, I'm showing in my laptop that it is looking like this. Say for example, y equal to 99. Again, I should assign from here, say 99, and then print y, then it will give you result. So various ways to execute the program, and it's very easy to install. It's very easy to learn also, and easy to implement also. So that's why Python is widely used everywhere at this present time. Now next topic, we have a Python conceptual hierarchy. We know at this point of time that we can go and write the program, and then we can save as .py extension. Now, what is happening that whenever we are writing the program, we have modules. Obviously, you have the blocks, and that block is nothing but the module. Inside that module, we have the statement of expression, and those statement that contains expression, they are nothing but objects. So everything in Python is an object. We have so many built-in object as well. We can write code to define the objects as well. And there is actually no concept of that you have no concept of that you are using some old expression or something like that, because if you see here the notes, you'll find that Python is considered as a dynamic language. One way to understand is it to see that Python does not require variable. That's the thing. That's the game changer. You can say that it does not require variable, but it's a dynamically we can go and assign the variable. Correct. So suppose x equal to 5, we are assigning dynamically. Means at that particular instance, you are going and creating one variable and you are assigning it. You will find that because it is supported or natively supported inside Linux, so most of the Linux operating systems, it's very easy to install and use as well. So here is one example, and it's not required in Python 3 that you should go and write like this. But what we can do that we can start with this shebang. This is termed as shebang, but it's not required. Let me quickly show you this, the same program in Python 3, because Python 2 is now, it is announced officially that will be out of support, out of live. You can think US, UL, etc. So there is no longer support for Python 2 in upcoming time. So what we should do, that we should go and focus more on Python 3 and the syntax. Correct? So let me show you here that how this program that we have look like. Let me write one program. Let me go and write here. So what is this? That simply you can go here and you can give, say, course equals Cisco networking programming. That's the course, because this is the string, so you should close inside the quotes. Either you can use single or double quote, but you should not mix a single with double, double with single, etc. And then you can go and print. Now in other versions of Python you have some issues like this, but when you are using the Python 3, you should use the syntax like this. So print the course, and here you can see that Cisco networking programming. Now here you can see the example is with the old version. If I go here and use a print course, it will not work. Okay, because it is telling that print is a function you should go and use in this format. Now next we have three very important terms here, or you can see the help utility function, that help, dir, and type. And this is actually very important to understand all these three. So help means, let me quickly read out this. Help means that we have the Python inbuilt document about the object. Dir means that what methods related to that object, and type obviously means that what type of a string or what type of uh, function or expression you are using, or what type of object you are using, to be more precise. So here if I go and say, for example, if I type x equal to 1, and then if I go and type x, so here you can see that type is integer. Okay, likewise if I go and do dir for x, so what methods related to x, you will find that these are the methods like avs, add, bool, seal, class, del attribute, dir, etc. So these are the supported method with the integer. Suppose x equal to a, that's the string. Then I can go and use, say, type x, and now here you can see that initially x was 1, now x is a, so we are dynamically assigning the variables. And then here you can see the type is now a string, and if I go and type, say, dir is say x, so you can see the methods related to string, methods related to integers, and then methods related to a string. Then finally we can go and use the help utility, say help int. So it will go and tell you the int related object. This is the class int object, and the methods inside this class, all these options inside this class. It is telling that you can do all these things. Likewise, I can press up arrow and I can go and check say str string, and then inside the string add, contains, equal, format, length, etc. All these methods it is telling that we can go and use inside this particular object. Okay, so that was the important information. The same explanation here also, just for your reference, you can go and read it. Then finally, we have to go and study about Python data type. So in upcoming session, we are going to learn about the string, number, list, dictionaries, boolean, and file. Although you'll find that all these um, important information that we have here as a basic understanding of Python are easy, and all these concepts that we are going to learn here, we are going to use in the advanced section, where we'll go and configure the network devices. There are so many operations that we are going to do. So we'll telnet configure, we'll SSH configure, we'll use various methodology related to SSH and configuration as well. Okay, so these basic understanding and knowledge of all these uh, data types or the objects is important in the upcoming future videos. Let us understand Python virtual environment. Now this is useful, and you can correlate this with router VRF type of thing. Like you have virtual routing forwarding instance. That means one router don't have only one routing table, but it can have multiple routing table. Correct? Like that, in same Python application or Python interpreter that we have in our system, I can run a multiple versions program with multiple API. So rather than installing different Python flavor in different system, we can test uh, we in our virtual environment we can test different versions of programming code with different set of APIs. Correct? You can go and check this link as well. Here you can see the explanation. Let's suppose if you have epic 1.1j and you're running epic 1.02m as well, and you are checking the API codes related to both the epic or ACI controller, you don't need to install the different Python package to check this. Rather than, you can work in a virtualized environment and then you can run these programs. All right, so how we can use the virtual environment? Here you can see I can go and log into my automation tool. I can go and check the Git installation, and before doing this, we should do the apt-get update. Once you do the update, after that you can check the zip installation. Then after that, you can see that we have command apt-get install python 3 v virtual environment. We'll go and do the cloning for one of the sites that we are going to use in upcoming sessions, so we can uh, reuse the code, or we can change the IPs or certain places in that code, and we can utilize in our program as well. So let's this get completed, although we have done these steps in the earlier sessions as well. It can be very faster, so we can wait for next 15 seconds here. All right, so it's almost done. Then I can go and do the git installation. Here you can see now we are getting the option. Once this is done, let's wait here. Then what I can do, that I can go and do apt-get install python 3 when, and this will also take some time. Done. You can see it's quite fast. Now I'll go and do the cloning for the git, and this will be the big URL. So github.com AI devnet, say getting started. So let me type the entire code here. This is long string. Even you can go to this URL and verify the coding and all. It's very easy to use with the web browser. So I can go and type the complete string started and Cisco SD WAN REST APIs Git. You can see it is doing the cloning and it is asking the username and the password because we have set that. I have the username and password and it is not found. Great. Let me try once. So you can see that cloning has been done. Maybe someplace I have some spelling mistake or typo. Alright, now I can go to this folder and you can see that we have so many programs that is there for our reference. Now, say for example, I want to run any of these program, even you can go and check. So this is for API related Python program. And I can go and check the others as well. So for example, login. What login is required? Do I have to set some environment variable or I have to go and manually put the login and the username? So at the moment you can see that I can go and run this Python program. This is actually the Python program. So I can go and run the stvan.py and few of the things will be missing. So don't worry. You will see in the upcoming section that how you can actually go and install these modules. While doing the installation, you will see that there is a requirement file as well, correct? So first of all, what you need to do here is that you should go and check this requirement file. Now, here you can see that uh, at the moment we are running this program in a Python library. It's not in the virtual library. Now, if you want to utilize the virtual one, what you can do, uh, step number 42 we have done, but here you can see these are the requirements. So Python 3.6 virtual environment, activate it, and then whatever requirements are there, we should go and run this. So before running this code, I just wanted to show you that what requirements are there that you want to install. So these are the packages, these are the libraries you want to install that will help this particular program to execute properly. So here we are putting the virtual environment and then it is going and installing all the requirement file, correct? So let it be completed. Now some of the places you can see that we have error. Now for those code, what you can do, you can go and search it and you will get the proper direction to install these particular packages, correct? Now again, if I go and run my Python code, that is the Python 3 stvan.py. If it is not there, then we can go and run. So now you can see clearly that we are in the virtual environment and we can go and run the program. Okay, so few places we have the error. We'll correct these errors in the upcoming section. The target for this particular session was just to tell you that you can run execute your program in the virtual environments. Okay, And still, if you want to check any of the small programs, I can show you, say, for example, nano hello.py, and then you can go and print hello, correct? And you can run the python 3 hello.py, and here you can see the output. Okay, so let's just stop here. We'll continue the labs in the upcoming section, where we have to go deep inside this, and then we have to execute the labs. Again, if you go and check the syllabus, you'll find that we have 20% weightage for SD-WAN programming. So better when we start the SD-WAN module, SD-WAN section, we'll perform these labs. And now we reach to 1.6, where we need to understand the benefits of Ansible and Puppet to do the automation related to iOS XE or even any type of operating system that Cisco has. Not only the Cisco operating system, but non-Cisco operating systems like Juniper and other vendors also is well supported via Ansible. So let's understand first of all that what is the importance, what is the use cases we have, and why exactly we are looking for Ansible or maybe Puppet to do the automation for our management related task inside the enterprise infrastructure. So we have different type of tools. So for example, Puppet, Ansible, Chef, SaltStack, and others. These are the topmost or the popular one. So we have Puppet and Chef. They are agent-based tool, and Ansible is agentless. Now, what does it mean by agent-based and agentless is that you have to install the agent or you have to install a small piece of software to all the devices to whom you want to monitor via these tools. That is not the case with Ansible. Ansible can run in the control system, in the controller, in the automation tool that we have, and then it can push the configuration, or it can send the configuration. Either it's related to configure the devices or to get the information about the devices to various networking devices. Now the next question is that why we are using this, why we are doing this. The answer is that, say, think about the operational case. Suppose if you have to create the VLANs or IP addresses or any type of failover testing, maybe you have n number of branches and you want to do the failover testing. Now in that case, if you are doing it manually, and this failover test you have to do, say for example, every month twice. Now if you do it manually, and from long time we are doing it manually, it is okay, we can do it, but it's time consuming, it is repetitive, and it may be error prone if you do some sort of typing mistake. Rather than these type of things can be done with help of program within few minutes, even within few seconds as well, depending upon what task you have and how much time it is taking for the programs to load and compile and then execute. That much time only it will take. So we have different type of tools that we are going to use to manage the infrastructure. Again, here we have to discuss about Puppet and Ansible. But yeah, there are so many tools that can be help to manage the tools. Now you can see this Python on and on and on, because Python, even for the Ansible also, that's a prerequisite. So you should have the Python module inside your system to run the Ansible, correct? All right. Now we are becoming the net DevOps engineer. So we are doing the networking. We should learn the DevOps skills as well to manage, operate our infrastructure. Again, the same repetitive things I have added here just for our revision, that if we are doing automation, we can avoid repeated tasks, any type of errors, faster deployment, identical configuration. It's easy to reuse the code. What are the tools we have? We have Ceph, we have SaltStack, we have Puppet. Again, there are some others as well. What is Ansible? It's open source, but now Linux has acquired that, I think long back. And the modules are open. Anyone can install this and you can use it. It's not a big deal. Even in my automation system, in my lab also I have the Ansible, and I can run execute the program. It need Python. So simple, agentless. It is a push model. How it is using here, you can see the comparison. When we have the Puppet master, we have the SSL connection and then Puppet agent in between that. We are running the Puppet, but when we have the Ansible, since this is agentless over the SSH transport, we can do the management of the devices. All the codes, everything will be loaded and executed at the controller node, and then it will go and push the configuration to the managed nodes. What are terms we should understand? We should understand YAML, Jinja, playbook, task, role, host, facts, gather facts, etc. These are the terms when you do the program you'll find. This YAML program will start with 3 dashes, and then here you can see that how easily we can read this program and what this program will do. So this program, the host is iOS routers. We are gathering the facts. No, connection is local. Now what is the task? To save the configuration, and how we are saving the configuration with write mem. So this command will go log into all the devices that is listed inside the Ansible host, and then it will write the memory. Means it will save the configuration. Again, we should have the list of hosts where we are pushing the configuration or getting the configuration. So we should have the inventory, and once you run execute this program with respect to inventory, it will give you the desired result. Let me quickly show you that I have one of the program in my automation tool and how my topology is. Here you can see that it is connected here. Let me scroll down. So I have one CSR device that is connected with my automation tool in this network, and I should ping to my CSR device before doing any configuration. Now I just wanted to show you that what configuration I have. I have ios.yml. It's just the program name. The working one is the site.yml. You can see what this program will do. It will go and check the show version from this particular device, correct? And let me check if I have other program as well, say cat ios.yml. This will go and do show run again. You can see the format here. You can see the host list. So it's very easy to read, and it's very actually easy to execute as well. Okay. All right. So let's stop. In section 2, we have to learn about automation APIs and protocol. You can see that overall weightage is 30%, and you can see the topics in details here that we have to understand about the data models, Pyang, the HTTP authentication, and the rest of the topics with the lab. What I have done, I have created some pre-videos. So before starting these topics, I have created some videos, some basic videos that you should know before understanding 2.1 up to 2.9. So please go watch these pre-videos, 1, 2, 3, 4, 5, 6, 6 videos, and you'll find this is very informative, and this will build the foundation. Once you complete these videos, then I'll go and start with section number 2.1. So please go complete these pre-videos. Solution of the networking, managing the devices, and the programmability. We know that the way that we are managing the device, that is still the case, that we are managing the device. Here you can see in the diagram that the operators, they perform manual verification. We are doing the telnet, SSH, or SNMP methods to log into devices. We can poll different type of information from the devices. When we are doing the troubleshooting, we are using the CLI. Still CLI is used for troubleshooting purpose. Then we have multiple other tools. Say for example, we can use multiple tools from SolarWind. or there are many vendors, they have tools related to trace route, or maybe to understand or to do some sort of visibility with respect to net flow and other inbuilt mechanism we have inside the devices. One of the key role that we have with the SNMP in the existing network is to manage the network devices. One of the good example for this is that SolarWind tool, that with the Orion SolarWind tool, we have the pollers everywhere. We are doing the SNMP configuration, and with the inbuilt MIB, and that's again the database, and that's again one type of you can think one type of object which has code related to MIB. That's the managed information base, and from that we are using some sort of get method, and then retrieval of data is happening. Now there are a lot of disadvantages of SNMP, although this is running from more than 25 years, this SNMP, Simple Network Management Protocol, to manage the entire IT infrastructure. This is good as well, but the capability of SNMP is not that huge. It's okay that we can have the inventory, we can check what's interface is going up and down, protocol is going up and down, etc. But there are n number of limitations we have with SNMP. So I'll list all the limitations that we have in SNMP one by one. Again, when we are talking about CLI, this is for human, this is not for machine. While the APIs are built to machine, that's is something like machine to machine language. But on other hand, it's very easy to read as well. So not only the machine can understand, but the humans can also understand different type of API and the format of API. Now, starting with this SNMP that evolved or developed in late 1980, and it was doing its job. We know that we have SNMP version 1, version 2, and now we have version 3. That's quite secure. But version 1 and version 2, they are community-based SNMP, means community, you can think at this point of time some sort of password-based system who is taking the information or who is polling the information from the uh, networking devices, or even we can push the configuration as well. We can push the script as well from the SNMP server to the networking devices. But still, the method that we are using is quite fixed and it's legacy. So let me quickly list you all the disadvantages that we have with the SNMP. Here you can see that SNMP is using, so let me quickly highlight this, uses a get request to retrieve MIB variable. That's get is nothing but type of show, like we are typing show run. Show is equivalent to get, you can think in the API world. Now here you can see the limitation of SNMP is that version 1 and version 2 are loosely secure. They are not 100% secure. It is not built for real-time communication, that's true. So it has the polling interval, and sometime it will take 15 to 20 minutes time to just get the information that what happened in the network infra. It has a lack of writable MIB, so all the MIBs are fixed. Again, the vendor, they will create the MIB, and again with the OS patch or code, the MIB will get updated. So it's not that you can write the MIB and you can upload. Okay, so that's the problem we have. This is the vendor lock writable MIB we have. Difficult to replay or roll back the configuration. You don't have library. So for me, these are the biggest disadvantage. Writable MIB, lacks of library, like say for example Python. You can have the libraries, you can use multiple libraries for different type of devices, and then you can use inside the code. That is not the case for the MIB. And the scale factor is missing, the security factor is missing, the real-time monitoring is missing. So those are the disadvantages we have in the existing networking model. And if you see at present the enterprise level, so many companies now they are doing the API based or the Netconf or Restconf based monitoring or the management system. Okay, so it's not that these things are not in use; they are already in use. And along with SNMP, maybe some places you'll find SNMP is used, some places you'll find mix of SNMP and the other REST-based APIs or other tools, programmable tools are used. Some places you'll find that 100% programmable tools are in use. So for example, 2015 Google has announced intent to disable SNMP for monitoring by 2017. So big companies like Google or say for example Microsoft or those type of networking giants, uh, they are very prone to the real-time informations. So 15-minute delay or 10-minute delay is a big lag, and they don't want to do that. So that's why in Google and in such type of big companies we have a real-time monitoring based system, and that is again a system based on the programmable modules or different type of APIs, REST API, XML APIs, etc. All right, so these are the problems we have with the SNMP. We have a restriction, we have locked, we can't scale, security, etc. So just to overcome from that, we are moving from this existing network. You can see that most of companies still using this type of networking solution to manage their networking devices to next gen configuration management system. Now, when we are talking about next generation management system, so at that time, the goal or the agenda is that handle machine to machine communication, correct? And what are the high points we have at this point of time is provide easier to use management interface, support client side validation and error checking. That's again the big thing. So we are validating the client side validation and the error checking. We have separate configuration and operational data. We have built-in backup restore capability, be both human and machine friendly. Now the moral of a story is this, that when we are using the programming interfaces, that's again the next generation management uh, tools. So in at that point of time, what is happening, that there are so many things that we already know. Those are the problems with the existing SNMP based management system. So new programming interfaces or the management tools, they know all the existing problem, and then they have created this system having those problem in mind. So that's why we have the support client side validation, error checking, management interface, say backup and restore capability, etc. These are just 5 or 6 points that you're seeing here. But apart from that, the biggest advantage we have is in terms of programming, that you can create or you can use the existing libraries, or some point of time if some company, say for example Palo Alto, when that company will write the libraries and the Python scripts, etc., we can reuse that code inside our infrastructure. Again, the other example is Cisco ICE. Cisco ICE is using ERS, means you have to enable the ERS, external RESTful services, to check that REST APIs. But if you go and check Cisco ICE programming infrastructure, you'll find that they are already given n number of Python script or other scripts as well to monitor the device from the scripts, to monitor these devices from the programmable interfaces. Likewise, you'll find that in SD-WAN we have n number of APIs, in Cisco ACI we have n number of APIs. So all these companies now, whenever they are launching their product, they are giving the REST API integration. Even PanOS now, they are supporting REST APIs as well. Uh, they are supporting XML based APIs as well and REST APIs as well. So having this thing in mind, that if suppose n number of devices that I have in the networking, and they are supporting same type of REST based API, that means the same type of programming structure or same type of a structure can be used to n number of devices. And that's the consistency we have to manage the devices from the programming interfaces. All right, so what is the solution? We have seen in the previous section that we have the evolution of network where we are using the traditional method like SNMP and others to manage the network devices. On other hand, when we are using the programming interfaces, when we are using the programmable glue to manage the networking devices, at that time we are landed upon model-driven network programmability. Now, so the question here is that is the model-driven network programmability or programming is the solution or is the modern way to manage the entire IT infrastructure? And the answer is yes. Why? Because this is independent of network devices. So either we have the Cisco, Juniper, Avaya, or any vendor device. All these devices nowadays, they have the programmable chip. They can understand the program, they can understand the application. Most of the devices, most of the networking devices nowadays, they can understand the applications as well, and they are built in a way that they can integrate with the cloud and the virtual world as well. So now the answer is yes, that with the programmable interfaces we can manage the entire infra. Now the next very important question here is that how and what will be the format of the programmable interface that we are going to discuss now. So now you can see that instead of CLI and Telnet SSH, we have the open APIs. Then we have the open transport protocol, we have the open data format, and then we have the various type of standardizations. Again, we have discussed this earlier that now we have n number of libraries that can be supported inside the programmable interfaces. That is, hence it's not possible in the SNMP based MIB because it's very fixed and very difficult to scale. So now the next very important question is that what will be the format? Say when you are managing the device either with SNMP or CLI or SSH, you are logging in into the device, you are doing some configuration change, and then you are getting certain output. But what in case of programmable interface or programmable management world? The answer is this particular slide. So now here you can see that you have your application on top. So let me try to highlight here. So we have the application here in the top, say app 1, app 2, app 3, and then we have the bindings. So we have model driven APIs, development kit, and the below 4 are very important. So what protocol it is supporting? It is supporting network configuration netconf, Restconf, gRPC. Now here you can see that netconf can understand the encoding of XML. So here is the important because most oftenly we are seeing netconf, Restconf, gRPC, XML and JSON, and then we are not able to fix it that exactly where it is going to be used. So from this diagram you can understand that the protocols are netconf, Restconf and gRPC. Their encoding format, so netconf can understand XML rather than Restconf understand both XML encoding and JSON encoding. In upcoming section, we'll learn more about XML and JSON, and I will do the lab as well. Likewise, the gRPC, they can understand JSON. Now, what is the transport? The transport is SSH, TLS, HTTPS, HTTP2. What is the model? Model is the data model. Now, you can think this and you can correlate this with the TCP layer where we have the physical layer, data link layer, network layer, etc. Correct? That's the internet layer and then the upper layers. So here, if you go bottom to up, that is the model, then transport, then encoding, protocol, binding, and app. So model is data model, transport is SSH, TLS, HTTPS, encoding is XML, JSON, and then the protocol Netconf, Restconf, and gRPC. Correct? So now we have the answer related to this question that, okay, since we are going to use the network programming interface, how we are going to log in into the device. So suppose if we have to configure a device, so for example, SD-WAN. So SD-WAN, we manage controller, they will go and use Netconf to push the configuration. Obviously behind the scene, the devices, they have the data model. So whenever we are doing the configuration at the level of GUI, that can be converted to some machine language, and then that can be pushed to the end devices. Correct? So this is the way that Netconf behind the scene can use SSH, and then it will go and configure the devices. Netconf will go and use XML, and then the transport protocol, and then the data model. All right, so what we are going to do in upcoming sections is that we'll go and learn more about JSON, about XML one by one. Okay, so again, I have given this diagram one more time because I found this is very important to learn, understand. So let's stop here, and next section we'll understand, learn about JSON, and we'll have to do the lab related to that as well. Let us learn, understand about JavaScript object notation. In short, that's JSON. Now we know that we have the encoding format, XML and JSON. So let's learn about JSON. Now this JSON is, if we know Python dictionary, it's very much similar to that. There is although one difference between Python dictionary and JSON is that JSON is supporting name value pair, but the Python, they are having Python dictionary, they have having the key value pairs. So that's the thing, we have name value versus key value. But once we understand either of one, either Python dictionary or JSON name value pairs, then it's very easy to understand one to other. So one, if you understand, you can understand the other as well. Now in this example, you can see that we have the programming started here, say ins underscore API, and then you have the name and value. So type CLI show version 1.2 SID EOC etc. So in this way that can be formatted, means the JSON program can be formatted. Now we have several examples here as well. I will show you in a while. Uh, JSON is, again, we know that this is nothing but the data encoding format. So we have XML and JSON. It's a easy to understand format because if you go and check the program, and I'm going to show you a few of the examples, you'll find it's very easy to understand because it is associated with the name and the value. And because this is easy to understand, and because this can be natively called inside Python, so the usability and the use case of JSON is huge. So what I'm going to do here, first of all, let me go and run one of the program. Here you can see that we have one program called facts, and then we have the host name, Nexus, OS, etc. So let me quickly go and run this program in my automation tool. Let me exit from here. So we are inside the automation tool. I can go and create this or run this as a script as well. So if I want to do that, I can create, say, nano and say py. I want to import the JSON, and then we can go and give the we can create the program, correct? So let's do this. What is that? And you don't need to give in multiple line, rather than you can go and give like this. So only 3 I have, and then I can close my parenthesis. Let's go and put the value. Now here you can see that when we are writing this format for JSON, you can see here that start with this, and then you should give the colon, and then you should end like this, and then the comma. Correct? So now let me put the value, say host name is say nxosv, and then comma. So this is the format for the JSON, the name and the value we are giving. OS, we can check the OS, say for example, I can go and give the OS 8 dot, and I should use it like this, 8.0. And then finally we have the final value, that's the location. So location I can give, and give that as a San Jose, and that's it. Now we should close this parenthesis, and as programming things that we should start and end in the symmetric fashion. Now what I want here, if I go and print, and I should use the bracket here, so print this program. So let me save it, and let's run this. So Python 3 sc.py, and here you can see we are getting the output like this, but what I am interested to show you this is, and before coming here I should copy this program. So let me exit from here, and I can show you this program. So this is the program that we have, and I can go to the Python, and here you can see that the program that we have, let me give line by line. So now here you can see that it is printing this program, and then we have the name and the value. Now if I go and check the type for the facts, here you can see this is the dictionary. Now what I want, that I want to convert this inside the native uh, Python programming. So for that, here you can see that it's in the dictionary format. What I can do, that I can go and facts1 equal to, say I can give JSON dump. So we have the keyword like dumps and load. I'm using this dumps here, and what I am doing, I'll show you. Let me execute this program, and then I'll explain. Same type of format, although we have used earlier in the networking automation programs as well. Now here you can see the difference. And now if I go and check the type, and type for the facts1, so clearly you can see that we have converted the JSON dictionary, and actually it is the native form inside Python dictionary, to the string str. Dictionary can be converted to the str with help of the dumps command, and that's why we are using the dumps. And then we have the given the indentation of 4 here, so the output will look like good. Okay, so that's the key thing that we have discussed about the JSON, and we'll discuss more and more about that as well. So here you can see it's very easy to use, and Cisco devices, so for example Cisco Nexus devices, they are using the JSON format inside the Nexus OS itself. So next what I will do, I'll log into the Nexus device and I'll show you that how it will be used inside the Cisco Nexus device. All right. So again, the same thing that I have shown you, the example you have. Now what I can do here, I can go to the Nexus device and then I can show you the host name. And this host name I want to show you in the JSON format, correct? So again, you will see that Cisco natively using JSON format as well. So we can use pipe and then JSON, and you can see the name and the value output. Now what's the use of this? The use of this, that once I have the JSON format, then I can use the same JSON format to create my Python program, correct? So here you can see, for example, when we are checking show VLAN brief and then the JSON, it is telling that what is the name and the value. Likewise, the same concept, so for example, key and the value, we can use inside our own Python program, correct? And that's the interesting use case we have, one versus the other. So here you can see that we have the VLAN output, and I'm going to run in the Nexus device that is there in the GNS. So let me quickly go and open that device. All right, so what I'll do here, I'll exit from here. First of all, let me quickly do the SSH to the Nexus device. Yeah, I have this Nexus over my GNS, and I can use, say, for example, show host name and then the JSON format. And here you can see the name and value. Like that, I can go and use show VLAN brief and then the JSON. And here you can see I have created some other two VLAN 10 and VLAN 20. And let me increase the space here so you can see it properly. All right, so here you can see the format that we have the default VLAN, say VLAN 1, and clearly we have the key and the value. So VLAN show brief VLAN ID, this, and then we have the VLAN, actual VLAN that is there in the system. Then the name is default, we haven't given even any name. Then the state is active, no shutdown. So all the VLANs, they are in the state of no shutdown. Likewise, you have the VLAN 10 name, VLAN 20 name, and this is the system generated number. So when we are going to use this inside the program, inside the Python program, we should use in the same type of format that we have. Okay, so this is the example related to Python. So we can go and use ID, name, and the state. ID, name, and state, and we can create our dictionary that can be used inside the Python programming. All right, so let's stop here, and in the next session, we'll learn few of the examples about JSON. Next topic, we have extensible markup language, or XML. Now there is difference between XML and HTML, although you'll find that HTML and XML looks very much similar, but there is one basic difference, and the difference is this, that the XML is designed to describe the data, and that's the key I want to highlight here. Let me quickly go and highlight. So here you can see that XML is to describe the data. On the other hand, HTML is to display the data. And that's one of the reason we are using HTML code to build the websites. Although the XML code we are going to use inside the Python integration or inside the API integration, etc. Okay, so here you can see the main difference, that one is to describe and one is to display the data, although the look and feel is almost the same. So the code will start like this. So again, let me go and highlight here. You can see that it will start with these brackets, and while you are going to end it, so when you're ending it, it will go and end with bracket and slash. So any of the code that you are seeing here, say for example INS API, it is going and ending here at INS API. Inside that we can have a small code as well. So those codes also, if you start, it will go and end like this. So for example, outputs, you'll find that outputs will also go and close here. Then you can see the body. So this is the closing of the body. This is the starting of the body. Now in between that we can put various information, and then those information can be called inside any program, say for example Python program. So for that I am going to show you the example as well. So we have done the comparison with HTML. HTML is to display, XML is to describe the data. On other hand, if you go and do the analysis or do the comparison with JSON, we'll find that with JSON is much more human readable, correct? And XML is not as much human readable like JSON, but still the use case is big. Again, if you are studying Palo Alto firewalls, you can go and check Palo Alto firewalls. They are supporting XML based APIs. So those APIs which is encoded, or those are supporting the XML format. Again, it is highlighted here that XML on other hand is used to describe the data. So how we are going to go and build the program, and how we are going to integrate inside the Python language, that I want to show you next. So let me go and open my automation tool. Alright, so I'm inside my automation tool, and here I can show you, say I have one example related to XML. The better way I can show you here is like this. So here you can see that note will start, and then note will go and end like this. Then in between, if you want, you can have the headers and footers. Those are the terms that we are generally using in the HTML code, but in XML also to, and inside that you have the information from, inside that you have the information, reminder, and then the body. Okay, so this is one of the general format that we have related to XML. I have one other example as well. Say for example movies.xml. Now this is again the data that I'm going to call inside the Python language. So here you can see that collection self, say for example new arrivals, and if I go and if I show you, so here you can see this collection is closing. So the starting for this program is collection, and then movie, and then again you can see this movie, and they are getting close. So you can think like this, that you have main program, inside that you have a small program. Say if I start type has local scope here, so type is ending here. Again the format, the year, rating, a star. So likewise we have created the movie title, say behind, enemy behind, and this is the description and the detail about that movie. So it is ending here. Like that I can go and create that information for the other movie, then other movie, then other. So we have 4 movies here, and you can think that the database of 4 movies we have here, that I want to go and call inside my Python program. So if I can go to the Python program, here you can see again this program is little bit bigger, but you can understand that first of all I have to go and create the handler, and again we have the integration of XML with SAX. SAX is again one dynamic form that can be integrated with XML. So first of all, in this program, what we're doing is that we have the class and the definition. Inside that, we are not calling anything at this point of time. So we have the class here, movie handler. Then again, you can see that we have the definition, start element, and then the end element. Like that, we have defined. And by the end of this program, you can see that we are calling that XML, that is the movies.xml. So what this program will do, that it will go and use the Python program, but the input is the movies.xml, and then it will print that all those movies that we have in the list. Now I have taken this example from the URL here. If you want to know more about this, you can go and check this particular URL on the top. All right, so let's go back and run the Python program. So I can go here and I can run the movies.py, and here you have the result. So the movie behind enemy line and all those movie, you can see that now it is very much the human readable format, rather than if you go and check the movies file, the original movies file that we have, it is like this. So here you can see that this is the XML format, and then we ran our program, and then we have the human readable format. We have called this XML file inside the Python program, and then the result is like this. So please go to that particular link that I am showing here, and then you can check the reference related to SACs, and then different type of handlers that we have, plus the class functions. The rest of the things we already discussed, that we have discussed about the loop condition, if and else. So those loop conditions are very much the same. Whenever you run any type of Python complex program, you have to give the conditions and loop. So multiple things or repetition will happen inside the loop. Data models. Sometimes it is referred as a next generation API. So now we have different type of APIs. So for example, XML API, REST API, but still we are looking towards the data model. Now before understanding the data model, you can see here the structure of the data model. So in bottom we have the data model. On top for transport we have SSH, TLS, HTTP, HTTPS. Encoding is done via the XML JSON. Protocols that is going to be used is Netconf, and we know that Netconf is used inside SD-WAN and in other Cisco solutions as well. We have the Restconf, we have gRPC, and then the development kit and the app. Now this is the stack for the data model, and again in upcoming session we are going to learn more about the data model. So the main question here is that why we need data model, although the CLI is doing good. We have used CLI from long years. So the answer for this is that because CLI don't have any data model or don't have any structure. In CLI, what we are doing, we are uh, doing some request. We are running some show run command or show IPint brief, etc. But we are not specific that the output that we will get will follow some sort of pattern. And since we don't know the pattern, after that we can't take those input, whatever output we have, those output we can take as an input, and then we can play around with those outputs. That's now not the case when we are dealing with the data models. So what will happen in this case, that say for example VLAN ID. So now let's discuss about this data model and few of the things related to data models. Say for example, when we are checking the VLAN, so what are the attributes we have with the VLAN? So here you can see that what is the range of the valid VLAN. So we have certain questions related to VLAN. So what will be the range of the VLAN? Can a VLAN name have a spaces in it? Should the values be enumerated and only support up and down? Should the value be string or integer? So now we have different questions query related to VLAN. And now we can think that, okay, how we can utilize VLAN inside the data model. Okay. So now in future, suppose if you go and configure the VLAN via Ansible playbook or maybe via Python programming, you will see that we have to put a certain structure, certain input for VLAN or any type of configuration that we are doing via data models. Okay. Now we have one common misconception that the Netconf or the Restconf, they are sending the encoded messages or values. So here you can see it's very important to understand is that Netconf, Restconf, gRPC, they are working as a protocol still for encoding, still for data encoding. We are using JSON format, we are using XML format, and that's very important. So maybe you can embed this JSON or XML inside your Python program or maybe other program, and then you can write certain code that you will get the result. Okay, and we have seen these type of examples as well. All right, so now what's our focus? Our focus is to check what is next generation API, and next generation API, we are talking about the robust model that is Yang. So let's stop here, and in next section we'll go and learn about the Yang data model object, or we can say the program as well. Next, we have Yang language, that is yet another next generation. And this is the fundamental behind the model-driven programming. Yang, that was introduced in 2010. So now it become quite mature, and we'll see that various flavors are there. So Yang model, and then we can think as non-Yang model. So Yang is not only the model which is model-driven, but we have other models as well. So here you can see if you want to learn more, you can go and check RFC 6220. Initially it was built over Netconf Protocol, but now it is supported a Restconf as well. It is a model driven. So here you can see that you have multiple objects, they are connected, and obviously that once you are calling one object, they will go and pull other object, and the hierarchy is like that. That's the one reason that will be used inside the programming as well. So Yang, here you can see the definition is that is a formal contract language uh, with rich syntax and semantics. Obviously, it has quite a long number of semantics, and it is supporting in number of functions or modules. Again, in the lab section, actually I have done the lab with respect to iOS XE, and in the lab section you'll see that we have so many features that is supported when we are going and checking the Yang model. Even I have my CSR device as well. So let me quickly log into the CSR device. I'll go and enable the netconf, and then you can see the capabilities that we have. So let me quickly log into the lab. So I have my lab here, you can see over GNS, and here you can see the CSR device. In the external network, I have my iOS XE devices that is connected, and here I have my network automation tool. So I can go here. Let me exit. I'm connected with the controller. So let me go and exit. Now I'm inside the network automation tool. What I have done in this CSI device that I should go and enable the SSH first. So for that you should go and enable the crypto key. So let me show you that crypto key generate RSA modulus 102. For that I have done first. Once you have this, then you should go and enable the netconf SSH and netconf Yang. That is with respect to iOS XE. So once we'll go and enable, say, netconf ssh, netconf yang, then what I can do that, let me quickly see the IP address, and I will go and log in via the yang, so we can go and check the capabilities. So now I can go to my automation tool and I can do the SSH. The username and the password is Cisco in this device I have configured. This is the IP, and then the port we know that is 830 for netconf SSH. And then I can go and use netconf. Password is also Cisco. Now you can see the capabilities. So here you can see the full list of Yang capabilities that we have with iOS XE. So it is supporting IP local pool, multicast, IPsec policies, even the SNMP MIPS. So many things that is supporting. Okay. So let's quickly go back to the slides. Alright, so now we have seen that yes, we have the Yang netconf support in the iOS XE, and later you will see in the XR as well. Because this is the industrial standard, so IETF, ITU and OpenConfig, these are the openness standard body. That means that most of the network vendors, they will support this. There are some common ground in between the Cisco, means Cisco devices can support their own Yang netconf model, or maybe they will follow the industrial standard as well, or Cisco has their own custom made model driven programming as well, that we'll discuss in the upcoming session, upcoming recording. So here you can see that we have this industrial standard IETF define open config group, then we have Cisco common, and nice example is that OTV feature is common in iOS XE and Nexus operating system. And then finally we have the uh, standalone as well, or the platform specific as well, and that is nothing but any type of feature that is supported only in Cisco. Again, remember two things. First thing is that the Yang is not only one model driven program. There may be other model driven programs supported other locations. And second thing is that we always have the customization. So maybe one vendor will have their own model, or maybe he has the common in between them. So customization is there, and other model driven programs are also available. In this and upcoming section, we are going to learn more and more about Yang data models and the plugins related to Yang. Let's just start. Yang 1.1, we know that Cisco has done lots of innovations, and they have created nice document related to Yang module. You will find their document, and there is one public repository, the GitHub repository, where you can go and clone that to your local system. You will find good amount of examples we have related to Yang, and Cisco has um, put all these Yang models related to network devices like iOS, iOS XE, etc. I will show you this repository and the different type of folders there related to different type of networking devices. So when Yang has created, at that time it was running 1.0. And now you will find that in all the programs, you can see that Yang, they have version 1.0. And you can see the release was 2016. And then what is happening that now inside Yang itself, so programming itself will find that we have versioning control. Now, Yang is one language that is suited for Cisco devices, but there are so many different governing bodies, and we are going to discuss about that in upcoming section, like IETF, we have the OpenConfig, etc. They are developing the open standard programming, open standard data modeling, options for all the vendors, or like generic type of programming models. Okay, so what's the difference? You'll find that in 1.0 and 1.1 means after Yang first version and now the version that is 1, you will see that there is some sort of version control, and in the language itself, in the model itself, will find that it will mention Yang version 1. Suppose if this version is not there, that means that it is the first version. Okay, so if it is mentioned 1, that means it is belonging to 1.1. That's the one thing. Next, again, I will show you in the upcoming video that you can go and do the git clone to this particular section. I have done that. Let me quickly show you here. Details we will explore in the upcoming section. So I have done this git clone, and then you can also do HTTPS and then the github.com, and then the repository that Cisco has created and shared with the community that is available for public consumption. You can go and use it. So GitHub Yang models, and then Yang, because it is already in my system, so it will show you that it is there. Now I can go inside this, and then I can show you that there are vendor. So once you go to the vendor folder, and inside that vendor folder, you will see that we have a folder for Ciena, Cisco, Fujitsu, Huawei, Juniper, Nokia, etc. Now, if you're interested checking for Cisco, and inside Cisco, you can see we have XE, XR, SPO, NX, etc. We are going to discuss this more and more in the upcoming section. All right, so this is just the startup for the Yang, little bit of advanced and more familiarity related to Yang models, where I just explained you that you can go to the GitHub and clone this to your local system for further lab purpose, further testing, further information purpose. Another thing is that in the 1.1, you will find that it is mentioned inside the code itself that Yang version is 1. All right, so let's stop here, and in the next section, we'll learn more about the Yang Git repository. We will learn how to navigate these folders that we have publicly available in the GitHub. Previous section, we have discussed about Yang 1 version, 1.1. And we have discussed about the fact that we can go and download the Yang model, their configurations from the publicly available site. Actually, we have two options. Either we can go and extract those automations from the network devices, or we can download from the internet. Cisco has put all those scripts inside the GitHub repository. We can go and clone it to our local system, and we can use it. Now we know that Yang is relying on the protocols like Netconf, Restconf, gRPC. We have discussed this earlier in our previous videos. Yeah, so point being here that you can download that. I have downloaded to my local system, and then we can go and do much more deep study inside those coding, inside those packages. So you can see that link. You can go to the Git and you can download that. And once you have downloaded, so I have cloned that. I have already shown this in the previous video that you can clone it, git clone. Once it is there in your system, then you can go and see that what are the available folders. So if I go here and if I can walk you through the available folders, you can see that I have Cisco. Not only Cisco, that we have the other vendors. So I can see that these vendors are available because this course is dealing with Cisco technology. So I'll go inside the Cisco. Inside Cisco, you can see that I have iOS XE, XR, NX, etc. If I go to NX and if I do there, I can see that different versions inside the Nexus operating system. If you can go to any of the version, so let me go to the 8 version. And then if you do there, you can see that you have all the Yang models available here related to different configurations like ACLs, BFT, BGP, etc. Now let me copy any one of this so we can have a quick look about that. I can go here and I can show you that. You can see that it is starting from the module. And again, we are going to discuss about this in the upcoming section about this configuration and what different components we have inside the Yang, what different modules we have inside the Yang in the upcoming section. But yeah, easily you can navigate. You can see it's descriptive, it's easy to understand. You can see the deviations and other differences. Yeah, it's easy to understand, and that's why Yang is one of the preferred language we have as a modeling language. And since this is a vendor neutral or it's a standard protocol, so any of the vendors, they can go and utilize it. Okay, there are README sections also where you can go and read that what are the available codings modules are available inside that folder. Okay, yeah, this is a vendor neutral, means different vendors like IETF or OpenConfigs are there. They are creating the models for other networking giants as well. So those things also you will get there. Basically, we are focusing on Cisco. So we'll go inside the vendor, choose the vendor Cisco, and then you can see that NX, XE, XR, etc. that we have. Then one by one, we can go and check all those in this programming course, because we are mostly going to focus on service providers. So we are going to see the examples related to XR, iOS XR platform. Okay, but yeah, if you're keen to check the others also, you can go and check the Nexus operating system, XE operating system, or if you're looking for some examples, some scripts, then also you can explore, you can search, you can do a little bit search inside the GitHub. Okay, so from where you will get some different authors, they are putting their scripts so everyone can use and innovate. Okay, again, you can go to the XR, you can check the README related to XR. This is for iOS XR platform, the directory, what are the contents that you will get, and all the time Cisco is updating their Yang package. So suppose if Cisco will go and release some new version, for example 9.3.10, so you'll find the modeling language related to 9.3.10 as well. Here you can see this is a little bit old slide. Here you can see it's showing only 5.3, but we have the new versions as well like that. There are some old snapshot. Now we have the latest iOS XR as well. You can get the package related to latest version as well. So if I go inside the XR, let's see, go to the XR and you can see we have 751 as well. And if you go inside 751, you can see TLF, good amount of scripts are there, open configs are there, different modeling languages are there. Okay, so make a clone of it, go and check all the vendors. If you have supporting multiple vendors, you can check other vendors as well. At least go and check the Cisco. Inside Cisco you have the XR, NX, iOS XE, and explore a little bit all these options. All right, let's stop here. In this section, we are going to discuss about various type of components that we have in the Yang. You'll find that Yang, different type of nodes that we have. We have 4 different type of nodes: leaf nodes, list nodes, container, and list node. Now, as name suggests, and it's easy to recall, leaf nodes are obviously the objects, but they are the smallest object we can assume of same type. So leaf nodes, they contains data of same type. You can think this as a small one type of object that you can define, and then you can put some parameters inside that. If it is defined for a string, that means it's a string. If it is defined for other integers or float, so it is for other integers or float. But they are smallest unit, and they are going to define the purpose is that for one entity, one type of data type. Now you can see leaf bandwidth, type, again you can see the units. So what other important factor we have? We have to understand that we have some sort of mandatory parameters inside that, and then we have some sort of optional parameters. So when we are defining the leaf node, and here leaf node is bandwidth, then we should have the mandatory data, we should have some sort of optional data as well. Okay, so you can see that the leaf node defined type of the node, and then the parameters that we have inside that is bandwidth, link state description, and the data encoding may be XML or JSON that we know from our previous videos, because we know that what is the protocol. Protocol may be Netconf, Restconf, etc. The encoding may be XML, JSON. Data model is Yang. So modeling we are doing with respect to Yang and others as well. We are going to discuss in upcoming section. Okay. Then you have the type keyword, then you have the units, description, etc. Okay. So this is about leaf node. Then rest of the aspects, rest of the nodes. This is it. Contains the data of one type, correct? Then while you're defining your models, you should have different type of nodes. So here you can see that list node. Obviously the name is suggesting list. So that means that you have your object. Inside that you may have other objects that you can define, correct? Then you have the container node. Container nodes means you want to call list inside list, container inside container, or list inside list node inside list nodes, etc. So there's a name container, as name suggests, container. It is going to contain something. And then finally, you can see the list nodes. So here you can see that two different type of node. One is leaf list, one is list node. Okay, list is again a little bit different from the container node. List means you can list different type of objects inside that, and we'll see that what examples we have related to all of these. So let's go and check secondly leaf list node. What is the example of leaf list node is that where a data model requires several values of single parameter. And here you can see that when we are defining one program related to IPv4 DSCP, you have the same type of data model, match IPv4 DSCP, match IPv6 DSCP, match DSCP. Means you can think like this, like you have node 1, you have node 2, you have node 3. Means three nodes, three leaf nodes inside the leaf list nodes. So node within the node or leaf within the leaf, you can think as a leafness list node. Then container. The example of container is very important because they are the data types or they are the nodes that can carry leaf, leaf nest, container itself or list, correct? So if you need to group different set of parameters related to the same object, a container node is natural choice. Correct. And here you can see that we have the container defined encapsulation. Inside that, I can go and give the description. Inside that, we have the leaf encapsulation. Inside that, we can go and give the leaf encapsulation options. Okay. So point being here is this, that the container that can contain other type of nodes type. And one other example, you can see that we have a container IPv4 network, inside that container data, inside that container input, inside that leaf. So inside container, we have container, inside container, we may have leaf as well. Like that, the model can define. Okay, the last one, we have the list node, and I have highlighted this in the red color. So the key difference is that typically list nodes are used when you need a similar set of parameter of many types. Correct. An example for this is the BGP neighbors. We know that while creating rules for BGP neighbors. We're telling, okay, BGP neighbor, then BGP neighbor policy is this. BGP neighbor password is this. Like you have same type of a structure, but in that same type of structure, few of the configuration lines are different. But you need same type of data model. And here you can see one example like list MTU. Again, it depends that how we are defining. So we have list MTU, we have leaf MTU, and according to that, we can configure it. Again, you will get some other great examples as well. We will understand that you have the list and that list having a small variations. Same type of data models with a small variations. Obviously, you have some optional attribute, you have some mandatory options inside that. So we need to figure out which is optional and which is mandatory. Here you can see that the key owner, key is there, so that should be mandatory. Then description and other parameters may be optional. So those are the optional, like that we can go and define. You can see mandatory is true. That means the leaf MTU is the mandatory option. Okay, so these are the 4 types that we have. Finally, we can go and do the grouping of the nodes. What does it mean? That you can create object with some other configuration, like I can go and do the configuration related to BFT, and that BFT configuration I can call inside the BGP container. So you can see that we have one configuration related to grouping the BFT, where we are defining the container BFT related configuration, correct? Now that BFT grouping, we can go and call inside BGP container, okay? And that's the use we have related to grouping. So we can define a grouping somewhere, and that grouping we can go and call inside other BGP information. All right, so this is the important information about different type of data modeling nodes that we have inside the Yang. You will get a good example, lab examples in upcoming section, or you can refer the GitHub as well. I will go and point you towards some of the example that we have inside the GitHub. Anyways, in upcoming section, we're going to do the configuration related to Netconf and Restconf, where we'll go and again, we'll check these options. In this section, we're going to discuss about deviations in Yang model. And in upcoming recording, we're going to discuss more about that. Now we know that we have the Yang standard developed via Cisco. Now, Cisco, when they are developing their model, obviously they are taking care of their products. And even in Cisco, also you'll find that different images are there, and different release and sub-releases are there. So the model that can work with Cisco IOS XR, they may not work with Cisco IOS XC with different iOS release, correct? And likewise, that is true with some third-party vendor. So the model that is working for Cisco routers, they will not work as it is with Juniper or any other vendor. Correct, and that's why we need some third-party Yang model as well. We need some sort of a standard as well. So that's the reason we have the standardized IETF Yang models. We have community-driven Yang, that is OpenConfig as well. Now, different models are there. The good thing about programming, any programming, is this, that once we understand the logic, we can implement that logic to any vendor. Only the syntax will get changed. And same is true with the CLI world as well. So CLI, for example, CLI OSPF for Cisco routers are different than the CLI OSPF for Junipers, correct? But the logic behind the OSPF protocol or BGP protocol or BFTs, they're as it is. So they are working same, only how we are writing the program is via CLI, how we are giving the instruction via CLI to Juniper routers, Cisco routers, HP routers, they are different. Different vendors, they have different type of configuration. Now, same is true here. So Juniper may have different type of Yang, because Yang that is developed for Cisco, obviously that will not work as it is as with Juniper, correct? So there are some deviation. It's not that the model will not work. Model will be the same for Cisco, for different vendors, but you'll find some deviations. If we know the deviations, or best practice is this, that you do configure Yang model for Juniper, different type of model for Juniper, and use different type of model for Cisco. But anyways, I'm not focusing in my labs and in my upcoming videos related to non-Cisco products. We are going to focus on Cisco product only because of first of all, we are preparing for Cisco certification. Other thing, my main interest area is Cisco. But if you want to see other vendors, you are free to experiment on that. All right. So the point being here is this, that even in Cisco also we have different operating systems. In Cisco also we have different releases and sub-releases. And that's the reason you can see the folder that we have locally cloned to our system, or you can go to the Git repository. You can see that deviations related to ISXE with this particular release. You'll find there are deviation in OSPF routing, ACLs, there are deviations in other packages, other features as well. Now, how we can verify that exactly there is deviation? So what Cisco is doing, because this is very well documented Yang that Cisco has uploaded to Git, and we can use it, that they are telling that, okay, if we have this release, so suppose if I have 3.3, and then I'm comparing with 3.17, or suppose if I have 3.1, I'm comparing with 3.17. So it will tell you clearly, interface, if interfaces IPv4 enable device deviate, not supported. So this is the format. If it will deviate in these operating system, they will not support. Well documented. Clearly you will get the information about the deviation, and it is supported in this package or not. But good thing about this, that if you go check the Cisco and vendors. So if I can go there, let me, so if I can go here. Yep. So here you can see the good thing about this, that for all the different images, like 661, 671, it's like 671, 672, 702, etc. We have different packages, correct? So for different images, suppose if you're developing the model related to 7.5.1, so please check this folder. If you have any image who is running 6.7.3, then check the programming related to this folder. So life will become easier, correct? So that's the deviation we have, and it is properly well documented inside the Yang documents, inside the programming folders, subfolders, where we can go and use the supported model to execute our program. Okay, and you will find that deviation, and then you can go and replace these deviations. All right, so we can stop here, but in the next section, we will go and learn about IETF standard and OpenConfig standards. In this section, we are going to learn about IETF Yang module and OpenConfig Yang modules. Now, why we need open standard? Because Cisco Yang modules, they are not going to cover all the non-Cisco products such as Nokia or Juniper, etc. Even within the Cisco as well, you'll find that different type of operating systems are there, different type of hardware and platform are there, and Yang modules are not suitable for each and every component that we have. Although the Cisco Yang modules are very good and they are covering almost all the technologies. But again, there are variations, and we are going to check those variations with respect to other vendors or some standardization governing bodies. Now, why we have IETF? Because IETF has been leading the standardization, and IETF has those modules that is not developed for Cisco or Cisco products. Okay, because we know that Yang directly belong to Cisco, and Cisco has developed and they have published this Yang modules for the consumption on the public platform, correct? So we can use those models, but still we have different vendors as well. And there also we want to use the modeling, data modeling. For that, IETF is suited. Again, we'll see that what are the drawbacks we have with IETF and what are the other options we have. Okay, now to compare to the number of native Cisco iOS XR modules, you'll find that the number of IETF open modules is insignificant. That means the growth that we have with IETF is not that great. It's a slow growing modules that IETF is proposing rather than the development of Cisco and non-Cisco product, because you'll find that Cisco having products, their release, sub-releases, etc. As compared to that, the growth of IETF young models, they are not that fast. They are slow comparing to that. But there are certain IETF models, they are widely used within the industry. Few examples are IETF Netconf. With respect to IETF Netconf, you'll find that there are good amount of developed models are there, and those are widely used. Apart from that, IETF Young model, they are supporting the NMS, they are supporting OS and BSS, basically related to telecom industry. They have the service models, and they are providing good support for L3 VPN, BGP, IP VPN, etc. Okay, so there are good examples like IETF Netconf related to telecommunications, related to OSS, BSS, related to L3 VPNs, BGP support. But still, they are lacking. They are lacking because the growth is not that great. And that's the reason the major giant companies such as Google, Comcast, Verizon, and Deutsche Telekom, they come together in a single open community platform, and then they have developed the OpenConfig. Now again, OpenConfig is good, and they are going to suit different non-Cisco products. They're going to suit because they are vendor neutral young modules, and they have the wide acceptability. But still, they don't have, at this point of time, they don't have all the modules for everything. Now here also you'll find the good examples. So the one of the best example we have with the OpenConfig Yang module is the data center deployment. With help of these models, we can go and quickly deploy the data centers. That's the one very nice example we have. But there is still evolution, but there is still a scope for the development, and the phase is going on. That means we are still in the transition phase where, with compared to the Yang Cisco, with compared to IETF Netconf, with compared to the OpenConfig, still we have a scope to grow there. Still we don't have the standard bodies, governing bodies. Still we don't have that much models for each and everything. So for example, related to OpenConfig, you'll find that OpenConfig is still they don't have good amount of models for EVPN, and we know that EVPN we are using for data center extensions and other places, correct? So yeah, scope is there. Either it's the IETF, either it's the OpenConfig, and things are growing. Now OpenConfig also we can go to the GitHub and we can download here. You can see the URL. We can download and we can use it. You can see a few of the examples. So go and clone this particular repository in your local system, and then you can have examples related to that where you can go and have a tight look inside those models related to OpenConfig. Okay, few of the vendors such as Arista, they are using OpenConfig only to develop their models, and whatever models or whatever configurations, they are not available publicly, they are not developed by anyone, so they are trying to support natively in their hardware. So there are companies, they are supporting OpenConfig because, again, if we are supporting OpenConfig, that means we are open to the market, open to the community. So any good development we can utilize in our native supported hardware as well, or native hardware as well. Correct. So the languages, so my hardware, which is supporting the language, which is OpenConfig, which is well suited because we have the community developed models available, correct? But again, Cisco, they have their own models, Cisco, mostly they are supporting Yang developed by Cisco only, and then in that line they are growing. So if we are in the public domain, means public driven, community driven domain, obviously the chance that we can grow will be the faster than the vendor neutral support. And that's the reason you'll find that most of the organizations, they also want to become vendor neutral because they want to become open, so everything will get supported. All right, so this was the example related to IETF and the OpenConfig. Let's just stop here. In this section, we are going to discuss about one of the tools that we have inside Yang, that is Pyang. Now, what are the benefits we have with the Pyang? So let me show you the list of the benefits that we have. Pyang can do the visualization for the Yang module in the human readable output, and I'm going to show you that. I will log into the device and then I'll show you that how the Yang module we can convert in human readable CLI format. Apart from that, it can create JSON or XML schema out of Yang modules, translate JSON to XML schemes, validate a Yang module, including imported and augmented modules and node. What we need to do here, we can go and do the pip install because it's a package, Python package. We can do pip install Pyang that I have already installed in my automation system. And once we have that up and running, then what we can do that we can go and generate the tree type of a structure to better understand the Python module that we have. So one of the module here, you can see that Cisco iOS XR if manager offer interface manager, that I will generate the tree structure, and you can see that tree structure here. Now it is very much human readable where we can know that we have the read, write or read only options. So you will see that in my example that we have either read, write or read only options. But yeah, it is a well structured format and it is generating the tree format that we can go and understand much more about the Yang structure. Okay, so let me quickly go here, and once you do the pip install, then you can go and run the command that I want to run here. And before that, what I need to do, let me go and quickly copy that configuration that I want to show here. So let me copy this, copy, and then I'll go to my automation server, and you can see that it is generating the tree format. And in this tree format, we have the interface dampening, and then you can see that inside that we have the tree structure, RO interfaces, interface dampening, and then RO nodes. So we can, from here, we can see that who is the parent, and inside that parent, who is the child. Then you have child, within child, you have the uh, child, or you can think as a leaf and tree. So you have the tree, and then you have the nodes. So that, like that, we have this structure here, module and the sub module also. We can think like one function, inside that you have one function, inside that you have one function. So here you can see the hierarchy, that interface properties are data nodes, then location views. Inside that location views, again, interfaces and their properties. Okay, so this is one of the nice tools to understand more and more about the Yang model. We can go and do pip install for Pyang. Once we have the pip install, then we can go and utilize this. Now, the next important topic we have is the Netconf. So let's understand Netconf. And Netconf, for Network Configuration Protocol, one of the use case for this, at least we have at this present time, is that if you check the Cisco SD-WAN fabric, you'll find that the vManage inside the management plane is using Netconf protocol to configure all the devices inside the data plane, or maybe to push the configuration to the control plane, other controllers as well, like vSmart. So that is the one of the use case. The other use case that I will show you here is that I'll go and log in to the CSR router. There you will see that we have so many capabilities related to network configuration or Netconf. Now, why Netconf is important? Because this is something called transaction based protocol. That means that if they do not do all the transaction, they will abort all the data. So until unless the 100% stuffs can be transferred, until unless they will not say in between, if you have any interruption, they will not send rest of the data. The second important thing here, you can see that the Netconf protocol having candidate, running, and a startup configuration. So not only that we have the running and the startup configuration, but we have something called candidate configuration as well. And suppose if you want to put this configuration, this candidate configuration, so there is one command called commit. You can go and do the commit, although we have commit verification or validate check, etc. So you can do and do commit check. Those things are also there. Means you are checking the commands that you want to put. So somewhere in between you have some transactional data is still not confirmed to push to the device. That will be working as a candidate. Running, we know that it is saved in the RAM and a startup is in the NVRAM, correct? So that's the thing we have. Now, earlier we have discussed that netconf is a protocol. This is not your transport method. So the underlying secure transfer, we have the SSH. Why we need netconf? That's the most important thing we have. Now, netconf is a new model for network management, and this is the transaction-based network management protocol that has much more capability than what we can do with SNMP. And SNMP itself has problem and vulnerability and restrictions that you cannot write the libraries. SNMP MIPS are preloaded inside the operating system. There are so many things. The most important thing we have with the SNMP in terms of the problem or the restriction is that it's very tight and it's very much vendor specific. On the other hand, netconf is widely used because under the data model, so it can be changed, it can be altered, and it is going to give you n number of capabilities that is not possible with SNMP, correct? So now this SNMP, even if we check the feature by feature listing between SNMP and Netconf, you'll find that Netconf has a huge benefit advantage with respect to SNMP. Now it can be integrated, the Netconf can be integrated with API, and this lab we have seen that we are using the REST-based API integration with Python, and you have seen that how fast it is to take the input from the centralized management plane, correct? So Netconf is the protocol that most of the companies they are looking at, and a few of the companies they are actively using as well. Now, what are the other features we have in the Netconf? They are the transactional based. They are using the client server model. And what does it mean? I will show you in the diagram. We have follow-up diagram to understand this client based communication or client server based communication. Now again, I told you earlier that netconf is a protocol. So the encoding method may be XML, may be JSON, correct? The the communication method may be SSH. So here you can see that SSH is the transport protocol for the client server model. So these things will be there. The good thing we have with netconf is the flexibility and feature and wide usability, correct? So here you can see the protocol stack with the netconf, and clearly we can see that the protocol, the message, the RPC and RPC reply, the layers, and the example. Now already we have discussed that we have get, we have four method. So in general, say get, put, post, and delete. So these methods we have, and apart from that, there are other methods as well, but these are the widely used methods inside the REST API or REST full protocol. Now here, one by one, you can see that we have explanation about the protocol. So what protocol it is using, the list of the protocol is SSH version 2, SOAP, TLS, what messages we have, although we have list of messages, few of the messages are listed here like RPC, RPC reply, the operations, what operations and how they are going to do the operation, we'll see that. So this client and server communication is going to happen over the SSH. Let me quickly show you that. Let me quickly log into the device and show you that how it look like. So here you can see that I logged into my lab, and this is my automation tool, and this is the CSR device. In the CSR device, what I have done, that actually I generated the crypto key, and we know how we can generate that. You need to give the host name and the domain name, and then I have given SSH version 2 here, and then I have enabled two feature, say netconf and netconf Pyang. That's it. After that, you will get the syslog message that your netconf is ready to run. You can go and connect like this. Now again, I have set the username and password as a Cisco, but you can give any strong password. Now I try to communicate to the CSR device with SSH. Obviously, the underlying protocol is SSH. And now if I click enter, you can see the capabilities that we have. Uh, all the capabilities related to the netconf embedded inside CSR. We have the long list of the features. So we have the data collection, we have the .3 OAM, gRPC, enhanced mempool, entity. You can see a long list of features that is there inside the netconf, correct? So this way you can go and communicate. Again, we'll discuss more and more about this communication in upcoming slides, how exactly it is communicating. Now what methods we have in the operation? So get config, edit, delete, copy, lock, unlock, close session, kill session. Okay, as name suggests, that kill means kill the session, close means close the session, lock, unlock. It's a widely used thing that you can go and lock the operation, or you can lock the configuration for some period of time, etc. Then delete, edit, copy, these are the normal operations that we are doing. Now again, you can see the transaction method we have running a startup and candidate. Candidate means until unless you can go and do the commit confirm, it will not push to the device. It will be there stored as a intermediate configuration, correct? Now how the communication is happening here, you can see that the client server model, client will try. So my network automation is my client. He try to send port number 830 with SSH transport protocol to do the communication with the server. Now what is happening behind the scenes? So here you can see the steps that I want to do the communication. For that, I just wanted to connect to the server. I will send my request, and then server will send the response. Here you can see the SSH, how I have done the SSH to the device. Now once I send my request, I'll get the response with the capabilities, correct? And we have long list of capabilities. Once you log in, you can see these are the capabilities. Some of them are listed here, but we have seen we have long list of capabilities. Now the client respond for the supported capabilities. That means I want to run some capabilities, maybe EIGRP, maybe OSPF. So now you can see the transaction is happening between the client and server model. So client is sending the query and server is responding. So first of all, server is responding that yeah, these are my capabilities, what you are looking for. Then client is sending, okay, I'm looking for EIGRP or OSPF, and for that I can send my operational code, whatever code I have like get, put, post, delete, etc. but in Netconf we have different like get, edit, lock, unlock, etc. And then finally you can go and do the configuration. Suppose if you want to do the configuration for any of the interface, shut, no shut, or any IP operations, IP related commands, you can go and do. So now you're sending the request for the configuration for the operation to the server, and then the server finally sending the response to the client. Okay, and this will be the summary slide we have. So you can think this as a step 1, 2, 3, 4, and 5, and how the client server model underlying protocol is SSH is doing the capability exchange. Actually the server, they have to do the configuration as per your operational request, you means the client, and then it will do the response. Okay, all right, so this way we can go and do the configuration for the netconf. Let's stop here. In 2.2, we have to understand the HTTP methods such as basics of HTTP, token, and OAuth. What I have done, I have created 3 videos here. First video will tell you about the HTTP basics, and I have compared the HTTP basics with REST API. So we'll understand the REST API, plus we'll understand the HTTP basics, how it is working. Next video, I've created DNAC related basic authentication token related lab. So if you complete video number 33, you'll understand that how HTTP token works behind the scene, plus the basic or the first lab related to DNAC as well. And in finally, third video, I have explained about OAuth 2, how OAuth 2 and its flow is working. So please go and complete these 3 videos, and then you're very much completing section 2.2. Let us learn REST. REST is a representational state transfer. What it is doing, and there is a misconception that this is very difficult to learn and understand. But behind the scene, what it is doing is that simply that how we are accessing or surfing the web browsers, the same way, the same method the REST is doing. So in the diagram, you can see that when we are retrieving any website, we are sending the GET request and then we are getting the page, HTML page. Now, same way, we can use the protocol REST. We can send the request as a GET, means we want to retrieve it. We'll see that what methods or what verbs we have. So we want to read or retrieve the information, and then we'll get the information either in JSON or XML format. That's how easy is this, correct? Now more hands-on lab will do, more and more will understand about that. So I am planning to show you the lab in the next session, that how you can do the lab from scratch. Alright, so REST is the method that is going to use various type of verb or methods. What methods that it is going to do, I'll show in the next session. But it's very much similar that how we are accessing the web browsers. Again, remember that we have the encoding in form of JSON and XML. What methods we have? We have this CRUD method. CRUD is nothing but create, retrieve, or read, update, and delete. So actually the methods that we have is the get method that you want to retrieve or get some information, is put method that you want to uh, update an object. You have post that you want to create new object, and finally you have delete, that means you want to delete the object, correct? So these are the methods that we have being used, and these are the top methods, means the widely used methods that we are going to use inside the CRUD. So CRUD is nothing but the methods or verbs inside the REST. This is a stateless client server model. That's true. Again, we'll see in the upcoming slides. Developed by W3C, proposed by Roe Fielding in 2000, and nowadays it is widely used. Even if you want to do the automation in terms of configuring, monitoring, uh, other stuffs like certificate management, uh, creation of object, deletion of object, in all those things are possible with the REST API. Obviously, you need to encode or you need to embed this method with some other method. So for example, I'm using Python to take these REST API objects or data, and then I'm converting with Python language in my table format. So I'll show you this lab in the upcoming session. Same way you can also use, and how you can use it I'll show you. So we have the CRUD method, we have the create, retrieve or read, update and delete. And here you can see that's interesting diagram, and it's very important diagram. So when you're creating, you are sending the payload. Let me go back. And that's very important because you want to send some data, you want to create new object. When you are retrieving or reading, the success code is 200. This 200 is nothing but your code method. So you are retrieving the information, you are sending query, and then you are getting some payload information, correct? Finally, if you want to update, you are updating with the payload. Finally, if you want to delete, you can go and give the reference and you can delete it. So delete is the easiest operation. Then you have the get operation, then you have the put, and finally the post. In post, obviously, we should be very careful while creating an object. There are chances that you can create the same type of object, so that you can use certain other keywords that the objects will not uh, collide. Or suppose if same object is there, if you are not using the force command, that means it will not get created because already you have the existing object. So those things should be taken care. This CRUD method we have, and we can do all sort of thing related to get, post, put, delete, and we have the patch as well. But mostly you will see that we are using get, post, put and delete. These four methods will serve all the purpose that we have. Okay, so get, that means you're retrieving the data, post means you're creating new object, put means you're updating the object, and again here you can see patch means update and modify. So slight difference in between put and patch. Put will update and replace a resource. Patch, again the name suggests patch, will update and modify the resource. Now what methods we have and what type of output will come into the picture, again we'll see in the next slide when we have the lab section. So once you go and do the REST API call, you will get these information. So first of all, you have the HTTP verb, means what you want. You want to get the information, so you can use the get method. Then you should go and use the full URL. I will show you that how it look like. Then there is some optional thing that body, if you are making certain changes, this is optional in what format you want the output. Again, if it is a post method, so we have the method plus the payload. And if it is a get method, we are doing the request and we are getting the output plus payload, correct? So you will find that you have the header, you have the key values that will be there, but we will look for the data field. And these data fields that we can go and convert with Python language in some readable format, correct? So again, you have the content type, you have the acceptance. You can go and run the API. I will show you again what are the tools available we have. So here you can see that we have the curl method, which is a very popular tool. We can go and use the web-based method, that's the Postman. But the thing that I want to use is the Python language. Python language, so because Python can interact with a number of devices, because now we have so many plugins, we have so many inbuilt programs as well, and we have so many resource code in the GitHub as well that we can go and utilize. Obviously, we can go to the Postman and we can do the query. I will show you in the next slide. All this information I'm going to share in the next slide. So before ending this recording, I just wanted to tell you that if still if you are in the Windows machine and if you have your PowerShell, so you can go to the shell. Once you are in the cell, here you can see the font size is very small. If I can go and increase the font and make this 24. All right, so now once you're here and you want to check this curl method, it's very easy. You can go and use the curl, and there are so many options we have with curl that you can go and explore. So I'm doing curl google.com, and then you can see that we are getting the result 200 is okay. That means success. You're getting the content related to Google page. Here you can see that the get request related to Google we are getting with the curl method. Okay, let us check about our lab. So the lab you can go and use Cisco sandboxes. Here you can see the URL, username and password. Two sandboxes are there: sandbox dnac cisco.com, sandbox dnac2 cisco.com, and you can see the username and password. Definite user is the username and the password. Now this is the lab, and we are going to run our APIs with respect to this lab. Plus, when we built our post related APIs, we built our delete related APIs, then I will use private sandbox, a private lab, and at that time I will show you that the lab topology and other stuffs. All right, so now we are ready for our first program, and that is related to authentication API. Now what is happening that suppose if you're running the APIs for certain task, at that time you need some sort of authentication token, means you are the valid user or you are the valid API user. Once you have that token, then using that token that will be associated with other API, other task related APIs, and we can execute certain task. Correct? So I'm going to show you this post method that how you can go and get the token. I am going to show you the token as well, that how with the program we are going to generate and get the token. Now in upcoming sections we have to learn and execute so many different tasks such as site management APIs, know your network APIs like client, your devices, client sites, etc. We have the command runner, template runner APIs as well, discovery APIs, connectivity APIs, etc. So long list of APIs are there that we have seen in earlier videos, and in the upcoming section we are going to learn about that. Now for lab 1, or for the first program that we are going to execute now, what are the things we have? What are the programs we have in this program? Now you will find that we have actually three different type of Python program. So one file I will show you config.py, or you will see that I am going to use a env underscore lab.py. Basically this will be one small Python program where I have stored the DNAC URL, the username, password, port number, etc. Now this is a variable file, and suppose if I'm going to use this variable file, so suppose this is the first program, and second program obviously I have the library API or library Python program. I will show you that the library name is dnac underscore API dot py, correct? And third thing that we have is the main program, correct? So main program. Now connecting program number 1, program number 2, program number 3, we will execute a certain task. Correct. So what I was telling about that program number 1, that is the config or environment lab, or env lab.py, that this will be your variable. So you are not going to do any change inside your library program. You are not going to do changes inside your main function. Means obviously you have to generate and develop your program. But once you develop your program, then if you are running those program, what is the reference? Which particular DNA you want to run? You want to run with respect to sandbox 1, you want to run with respect to sandbox 2, or you have any private or enterprise lab or network, correct? So that's the thing here, that's the scalability here, that the environment lab, we have to change the variables, and once we change the variable, then the library and the main functions will be as it is. Now in future, if we have the library, so suppose in future, if we have a new task, correct? So suppose if I have new task, then you can write your program. I'll write PR as a program, and then that program will point to the library. So that means inside the library, I have to go and create new function like function 1, function 2, etc. And then in the program, well, the program will go and call that particular function inside the library. Correct. So you can see the reference point here, that you have something called the variable, and then the variable is referenced inside the program, and program is referenced by the functions inside the DNAC API or the library. Correct. So let me quickly show you the program first, and then we'll go and proceed according to that. So here we have the program, and here you can see that I have my main program. What this main program is doing, that although it's a small program here, and inside this a small program, let me take the drawing tool here. Let me take a pen here. Yep. So here you can see that I'm importing certain packages. So import datetime, time, request, JSON, URL library, all these functions or all these packages that I'm importing is not required for this particular program. Okay, but what we need to import the URL library, and from request.auth the HTTP basic auth, and again from URL library 3 exception import insecure request warning, otherwise whenever you run the program it will generate some sort of certificate errors, correct? And then finally, so what important things we are importing here, let me clear the drawing. So we are importing, very important thing here is the DNAC APIs, line number 15. And then we are importing the DNAC URL, you can say URL, the password and the username, that's the line number 16, from one of the function, one of the Python program, that is environment underscore lab, env underscore lab, correct? Now you can see the main body here. So the main body here, it's get the token. So DNAC auth is the name, and this DNAC underscore auth is calling something from the DNAC API. So you can see that DNAC underscore APIs is my library Python program. It's a big program. From there, we are calling one function, that is get underscore DNAC JWT token, and then we are printing that token. And that's the whole idea about this particular program, is that we want to print the token. So you can see the program itself is only of 2 lines, but you can see the overall structure of the program, where we are importing certain packages or functions, then we are defining the main function. Inside the main body, we are writing our sub function or sub routines, and then finally we are closing the main function, correct? And this is the overall structure of the program we have. Now what we can do, that we can go and refer the other programs. So let me quickly show you the variable that we have, that we are calling actually. So that name is environment lab, and now here you can see that the DNAC user, the port, username, URL, password. And suppose if in future I will use some private lab, section. So here you can see this is my private lab section credentials that I will use in upcoming sections as well. And because we have used this comment here, that means they are not used. Means in Python, if we use this pound symbol, that means they are not used inside the program. And then finally, we are referring our main function. This is the library function, and you can see this is a big, so many lines are there, but again, we will learn and understand this in future more and more. So we have already understood the import functions that we have, and then you can see that we are calling this function, and in this function we have the API for the token, correct? So let me highlight those things. Let me scroll a little bit down, and let's check the API related to authentication token. So the API related to authentication token is API system v1 auth token that was there in the slide as well. Then we have the header, and then we have the response where we are using the post method, and that's the key. So we have different methods like get, put, post, and delete. So we are using this post method, and from the response, so you can see that from the response, we are taking only that field related to token, and then it is returning the token. So this is one of the classical example that how we can build a function with argument. So what's argument we have? The argument we have is the dnac underscore auth. Correct. So now this is the execution time. I can go here, and my code is inside this particular folder. So simply I can go and run that code. And what's the program name we have? The program name is get token py. So I can go and use get token py. So let me write that. And now behind the scene, the query is happening and we are getting the valid token. Now this token is belonging to which particular sandbox? You can see here the sandbox is sandbox tnac, correct? And suppose if I make this 2, and if I go back to the program, because that is the different sandbox, so now you can see that this time it will generate a different token because this is belonging to different sandbox, correct? You can see how easy this is, but there are so many baby steps involved here, and this is the same way that in future we are going to build our programs, correct? So let's stop here. Three-legged authorization code grant flow. Now in this section, we are going to learn that in between the client, so we have the client, we have the server, and we have the user. So in between our user and the server, we have the third-party client. And if this third-party client need to access the resources, how this authorization will come into the picture. So we are going to learn the auth flow and how this auth flow is going to give the security in between the user and the server. Now, when it is talking the user and server, let me quickly show you the diagram. So suppose we have the end user that is termed as a resource owner, and he want to open any of the resources hosted anywhere in the cloud. And for that, I have one client software installed in my laptop or in the user laptop. So what this user will do, it will go and open his client software. You can see the client here. And then he can go and access the resources. In this example, it's the Google resources. So he want to read some Google Docs. He can go click his Google document client, and then he can go and access the resources, correct? But here you can see that the end user, in between the server and the end user, we have two pieces. And we need to understand these two pieces. We have first of all the client, and secondly, we have the authorization server. So that means when the resource owner, he want to access something over the resource server, and he don't need full permission, means he don't need full admin permission to access the resources, rather than he need that access for a limited duration. So what this client will do, it will go and generate some sort of token. And with that token, the client will go and initiate the API call to the resource server. And then those resources, the end user will get, and then he will read that document. Correct? So I'm going to explain you complete workflow here, but we need to understand that we have 4 components here. We have the resource owner, who is the actual end user. We have the client, is which particular client software we are opening. We have the resource server, from where we are getting the document. And in between the resource owner, client, and the resource server, we have something called the authorization server, who is going to give us the token, who is going to give us the IDs, and that token, that ID will be limited for a duration. With that duration, we want to access that particular resource. So from the resource owner to the server, these tokens will come into the picture. Correct? Now let's go and understand this little bit in detail. And here we have the complete workflow. You can see that a resource owner, so here is the resource owner, wants to access something. He wants to read something. So what he will do, he will go and do the request to the client. Means he will go and open the Google Docs in his laptop. So read my book from Google Doc or Google Book. Now the client will respond that you need authorization token, means I need actually authorization token. Can you get me the authorization token from the authorization server? So client is responding to the end user, and then what end user will do? End user will send that request to the authorization server. So here you can see A3, this is the step number 3, authorization server. I need the client ID, I need the redirection URL, I need the access token, etc. Means you can see here the list of things that he will send in his request: response time, scope, client identifier, state, and redirection URL. So this is the communication. The A3 is the communication between the end user and the authorization server. Now, authorization server, he will give him the auth code, authorization code, and inside that auth code, he will redirect the user towards the client. Okay, so here you can see that step number actually A, inside A we have A1, A2, A3, and you can see that the B, that means when A3 will end, the server will give him the permission, and then he will redirect the user inside C, that you can, user A, I am redirecting you towards the client. So now, once the step number A, B, and C will completed, then the client and actual authorization server communication will start. And that's why this is the 3-legged OAuth 2 version that we are discussing here. So now the client and the authorization server, they will do the communication directly, and then the client, so inside step number D, the actual client will ask the authorization server for the authorization code for a certain duration of time, and with the redirect URL. Once the authorization server will give the access token on behalf of the end user, because actual requester is the end user, that is the resource owner. Correct. So once the step number A, B, C, D, and E, here you can see access token will get completed, then a step number F will start. That means the client will go and send the actual API, so authenticated API calls for the Google Read or the Google Books. So now the resource will get open, and then the client, and then actually the actual end user will get the resources. Okay, and then he can read the book during that particular duration of time. Correct. In between, you can see that one other step is highlighted here. Why? Because there are chances that token will get expire. And this thing we have discussed in our previous sections as well, that tokens may get expire. So in between the client and server, they will do the validation of their tokens and they will regenerate the token. So the end user, the actual resource owner, can read the book during that duration as well. Okay, so you can see that this is going to provide you the extra layer of security in between the actual resource owner and the actual resource server. Correct? Because these tokens are getting generated for a certain duration, for a certain task, and it has a redirection URL as well. Once you go and close that particular app, once you go and close that particular book that you're reading, then this process will get completed, and then the actual resource owner and actual server, they are get separated, and obviously they are safe now. All right. So this is the step related to OAuth 2 three-legged authorization. Next, we have 2.3, where we have to understand different type of data types such as JSON, XML, YAML, plain text, gRPC, and Protobuf. What I have done in the previous section, you know that you can go and check video number 18 up to 21, where I have covered JSON, XML, YAML. Now, rest two topics, gRPC and Protobuf, I'm going to cover in the upcoming sections, but before that, I have covered section 2.4 and 2.5. Okay, so already we have covered these many topics like JSON, XML, YAML that we have already completed. Next, you please go ahead and complete section 2.4 and 2.5 after this video. In the upcoming section, I'm going to cover up gRPC and Protobuf. In this section, we are going to perform the lab task related to NSO, Cisco Network Service Orchestrator. And in that lab, we are going to perform task related to load the lab, first of all. So load the topology on NSO. And we are going to use the load the viral topology inside NSO, then deploy L3 VPN via user interface, then via CLI, and then with respect to API. Now, the main concept behind this, we should get a little bit familiarity about NSO, because section number 4 in this course is completely dedicated upon NSO, where you will learn more and more about NSO. At this point of time, because since we know about the Yang, since we know that how the Netconf, Restconf, they are working, so I just wanted to give you some familiarity related to NSO plus Yang plus the API. And that's the reason we are doing the lab. Again, the target behind this, that with respect to section number 4, I want to touch upon the Yang model, and inside that Yang, when I will go and log into the Postman, you'll see that you are seeing the JSON format and XML formats there. Okay, so in section 4, I will try to cover 2.4 and 2.5, because we have to identify these models inside the Yang, and this is the perfect example to understand that. Okay, so let's start the scenario 1 and 2. First of all, we have to start with 1, where we have to load the image. So I have the viral topology, and you can see viral topology is full-fledged, where we have the P provider. You know that concept, P, and then you have PE, and then you have CE devices. Now the PE devices that we have, so let me circle it. So we have the PE devices, and with these PE devices, you will find, so you have one provider edge, other provider edge, other provider edge. These are iOS XR. And then the CE devices are normal iOS devices. Okay, so we are going to apply first L3 VPN inside provider edge. So here PE0 and CE2, and in between there to PE1 and CE3. Okay, so this is the target area where we want to apply the L3 VPN with respect to UI, CLI, and the API one by one. Okay, so before doing that, let me go and load the image. Let's log to the NSO. So here is the URL. When you try to log in first time, so let me try to log in, and it's loading because it's still booting up. Meanwhile, I have the CLI access, and in the CLI, you can see that this is the IP. Make sure that this is the correct IP that we want to log in. So let me try one more time to go there and log in there. So the correct URL, and let me give the username and password, log in. Now we are logged in, and what we want to load the image inside this. So let me click to the web UI. And once the web UI will come, you will see that we have the viral image topology loaded here, but you will find that they are grayed out. That means they are not active. Once you go and activate these devices, you'll find that the color will become blue. So parallelly, I will log in here to the NCS, and meanwhile the other screen is loading. What we can do, I can go to the config. You can see the basic command prompt config. Once we are inside the config, then we can go and we can load the topology. Let's see home, and inside that I have viral.xml. Now we know that if we do not commit here, it will not do their magic. So before doing commit, I just wanted to show you, show device list. If I can show you, otherwise I have to go exit from here. So after commit, I'll show you the device list. But before that, make sure that we have the topology loaded here. Let me refresh the page one more time. In the lab environment, it is a bit slow. All right, so let's give some time to load this. Okay, so I can go to view, and you have this L3 VPN. And now you can see, all the images are still loading up. It's a grade. So what we need to do, I can go here, and once I load the merge, then I can do the commit. Yes, great. And then after commit, obviously I can exit, and then I can show you the show device list. I can see the devices here, but we need to make sure that these devices have been synced, correct? So what we can do a request device sync from, and then you'll see that the NCS, they will go and they will try to contact the devices. You can see everything is true. That means it's good. So all our CE, PE, and P devices, they are synced. And now what I want to do here is that I just wanted to refresh the page. So let me refresh this page one more time. Okay. So once it will get refreshed, you'll find that they will start showing blue. That means that they are merged and they are synced. So now the viral is synced with NCS or NSO. And then once it is done, then what we need to do, we have to go and start the scenario number 2, where we want to configure the VPN. We have to configure the VPN in between CE2. Let me say this is the path, CE3. This will be the path in between that. And then we'll go and do a little bit of verification. Right, so let's go back to the CLI. Let's go back to the GUI. Now you can see these are becoming blue. To do the configuration from the user interface is quite easy. What you need to do, that you have to drag and drop the CE2 and add the VPN. Okay, I'll give the name for this VPN, say site1. I can give any distinguisher, correct? Now, once we have the site, then we can do the drag and drop. So I can drag this leg here and then ID. This is HQ as per our plan. Gig00 is for management, then IP network. So IP network, I can give one place I'll give 11.11 1.0, other place I will give 11.11 2.0. Bandwidth, I'll give any number. And then I need to give the AS number. So one device I'll give 65201, other place I'll give 65202. Click OK. You can see it's showing here. Now this is for CE2, and then I want to create for CE3 as well. And this CE, any other site that we have should give 0/01, 11.11 2.0/24. Bandwidth, I'll give little less. AS number 65202. Okay. Now we are doing the configuration from web UI. You can see how easy it is to. This doesn't mean that we have done the commit. If you want to verify in the commit on the top, you can see that we have the option to check the commit dry run. Now it is loading. So you have the Yang format, correct? And you can see that iOS, see local node device C2 config. In that, we have done this configuration related to bandwidth, shape. Then you can see that we have given the description as site1. We have given the address, correct? This is the local address 11.1, the IP address /24. And then we have a link to PE, correct? So we have the PE link and some default configurations are there. So leave it. Likewise, you can see the configuration for the other route as well. So this is the complete configuration in the modular format that we want to push. And then finally, you can see the VPN, L3 VPN related configuration. So one is site1. Inside that we have the RD 777. And I need to check that other place I have given the RD or not. So let me close this. From here, you can go on top, you can do close it. And we can go a little bit back. We can see that that device detail, because this is the nice orchestrator where we can go and check good amount of informations. Okay, so it's okay at this point of time. We can go back and we can do the commit. Let me go back to the main dashboard. Web UI. Loading up, give some time. And meanwhile, I have my CLI as well. So I can go to the CLI C2. I can show issue IP int brief. You can see that we have the IP here on gig0. This is the old IP 10.0.0.0.1. And what about C3? There you have 10.1.0.3. It's okay. And some loopback configuration. Let's see the BGP configuration. No BGP configuration we have. And we'll go to PE0. Let's see the BGP. And because this is iOS XR, so you'll find that the configuration will be a little bit different. Meanwhile, the GUI is also loading. Give him chance to load. And I can see that we have missed because we haven't done the commit, uncommitted change. So we're not showing anything. Include BGP. Show run BGP. Okay, let's see. Because in XR devices, you have a little bit different format. All right, just wanted to show you that BGP configuration here. You can see show out to BGP, and configuration should be going from PE to P, and it should go from PE to CE as well. All right, so I'll come back to this. Meanwhile, let's go back to the CE, and oops, I can see it's showing cancel. Okay, so you can see that we have the configuration here. Now I can simply go and do the commit. On top, you can see we have the commit option. Yes, I want to do the commit. And once we do the commit, then again, I want to go back here. I just wanted to show you. Show IP int brief. First of all, you can see gig01 configured like this, and the sub interface 1.97 is going like this. Now, if you go and check the BGP configuration, so we have the BGP configured here, and BGP configuration with AS. We know that this AS belongs to here, correct? And some MPLS configuration are also there. You can see the route import and export configurations are there. Site 1, we have the policy pass, and you can see a little bit down that now they are having the BGP configuration. So my iOS XC, that's the P routers, also getting the BGP configuration. And if I go here to the CE also, you can see that BGP configuration. Now I can see that this is up and running from last 1 minute. Like that also here you can go and check the BGP, it's up and running from last 1 minute. Sounds good. Now we go here and check show BGP, VPN v4, and if we have unicast, you can see 11.10, and you need to check the topology. So PE0 is connected with CE2, and CE2 having IP. Let's see what IP has. CE2 has 11.11. So one IP that PE0 is getting, it's a local, other it is learning from other place. But anyways, what we want to do here, that we want to use the trace route for 11.11.2.1, and with my source. My source is 1.1, correct? I can see that how it is going. It's going to P, then it's going to other P, because these are the MPLS level forward tables. And then finally it is reaching to a destination. Okay. Point being here is this, that you have seen the dry run, and inside the dry run, you have seen all those differences that is recorded. You can pause the video and you can have a look on that, because now it is already committed. So we can see the full configuration and how easily we have created the L3 VPN in between CE2 and CE3. Okay, so this is the way that we can go and do the configuration. In this section, we are going to discuss the scenario number 3 and scenario number 4. And we are, means once this configuration will get completed, then we will see that the use of REST API, and with help of REST API also you can do all those configurations. You can see the flexibility now. The UI is there, CLI is there, and then the APIs are there. Yes, for scenario number 3, for the CLI, I have the configuration in my Notepad, let me first of all quickly go and log into the NCS. Seems I lost the connectivity. Let me re-log in to these devices, at least NCS. Now I'm inside NCS, and you can see that to do the configuration, now in this configuration, we are going to configure the CE devices belonging to CE0, CE1, and CE4. And you can see the interfaces, the IP network, the AS number, bandwidth, very much same type of configuration that we have with the UI. Same we want to do via the CLI of NCS. Now for that, we need to go here to the NCS and we have to switch the CLI. Now we can do like we can do inside Cisco config terminal. Once you are inside the config terminal, then we can go and push this configuration. Obviously, after pushing this configuration, you have to do the commit. And we have option commit dry output format native. That also we can use. We can do commit dry and out format native and CLI. The options we have. Okay, so we have done the committed, we can end. Once we end, now if we go to the GUI, so now if we go here and do the refresh, we'll find that it will go and add all those configurations that we have done from the NCS CLI. It should reflect here. Meanwhile, it is loading up. I can go and log in to the other devices, like we have CE0. Let me log in here. And we can go and check the BGP. I can see that we are getting the relationship, but it's not showing here. Even I can see here anything configured. So let me see one more time. You can see that what I have done, I haven't done this commit dry run output native, and that may be the reason it's not getting configured. Anyways, let me go back here one more time. And let's go to the NCS config T. Commit dry run and the out format is native. Commit. I should do end here. So after committing, you should exit. Oops. End and exit. And let's see. So once we do the CLI configuration, it should reflect here inside the web UI. And we can wait since it is loading. Yeah, so you can see here, we have site 1 and site 2. Site 1, we have done the configuration HQ and SVT. And inside site 2, you can see that we have branch offices and main office, and those configurations are there, correct? Now let's go back here, and if I can go to the CE, yep. Now it is receiving the prefixes 11, 14 that we have done the configuration here. You can see 11 and 14. That means the configuration is taking effect. Okay, what I'll do, I will copy the running configuration for these devices and I will upload with the recording. So you can have a look inside the configuration. Great. So this part is very much done. What we want to check, verify this is that with respect to RESTful API, how it will be. So I have my Postman plugin here. And inside my Postman plugin, you can see I have NSO L3 VPN. And the first API here, let me scroll down, is the list all the VPNs. So if I go here and if I click send, it should give you the list of VPN, site 1 and site 2. That's correct. Now you can see that the output format that we have, it is in the XML, correct? HTTP/TLF is the header, and then you have the body inside that. But here you have the options you can see in the JSON. This is a JSON XML format. But yeah, we have the option here. Again, you can see that two formats are there. One is list VPN in XML, list VPN detail in JSON. So I just wanted to show you the differences because we want to hit the YAML format encoding inside the XML. So you can see that a list VPN, the API is here. API will go and give you the L3 VPNs for site 1 detail. And inside that you can see 11.1.0, 11.11.2.0, all this configuration, correct? And then we have all these encoding. We know that these are the APIs. You can see the checksync, deep checksyncs, etc. Now what I can do here, wisely I can go here and I can make this as a site 2 and then send it. And inside 2, now you can see 10.11, 10.14.14, 10.10.10.0, main office, branch office. So simply changing a small parameters and you can see that we are getting the output. Again, this is in the XML encoding format. If you want to see the detail in the JSON format, let me go back to the XML. Yeah, XML. JSON. So JSON format is, you can see it's different. It's like a string. A string means you have this string and inside that you have the value, very much suitable for the young models as well. Very much suitable to give the payload inside the function. I have one post method. I'll show you that. So now you can see that get the details for site 1. You can see the site 1 RD. You can see the IP. You can see the bandwidth. You can see all those configuration, correct? CE2 and CE3. This is in the form of JSON. Then if you want to create the site 1, what you need? You need the post method. You need the body. Inside that body, you should have the configuration, correct? So RD is 5555. You can see rest of the names are almost the same. I can make this as a SVT1. I can make this as a site 1, 2, 3, correct? Click send. Now just try to send it. And meanwhile, what we can do, we can go back here. I just wanted to refresh this page. So the site 1 should show you site 1, 2, 3. RD should show you some other number, whatever we have given, correct? Now these information we can verify from here as well, from the CLI as well. We can go to the PE0. Once we have the PE0, we can check show. Even I can do show run as well. From there also you will see if it is pushed. You can see that the difference is not coming, but I can see one new site has been created. And inside that also I can see CE2, CE3 with all those parameters. So it doesn't mean that it has removed the other configuration, but you can see that our API is working fine. And with respect to API, we have created the site called site123 instead of, because the name is different, that's why it is creating new site and everything is there. But we can do next here, I can go back here, delete VPN site 1. Why not delete the older one, correct? And simply the API is there. Parameters, let me show you if I have anything to show, because this is just a delete, correct? So let me delete the site one. Going on, and I can refresh this page. Now we should see the response, correct? So the response, I can show you the parameters and come on. I mean, we can verify it before sending there, and you should see the response at 200 success, correct? Yes, let's go back to the, here I can see clearly that site one is removed now. Now we have site 1, 2, 3. You can see the RD, we haven't done anything much with the RDs, but it's okay. Whatever RD was there in the payload 5555, because initially our RD was something 777, correct? So RD got changed, this got changed, the rest of the configuration is done. So see how easily we can do the configuration with respect to API as well. Okay, and then we have seen the differences as well in the XML encoding, in the JSON encoding. So this is one of the nice example. With respect to example itself, we understood the differences in Yang and their encoding methods. All right, let's stop here. So far I have covered section 2.1 up to 2.6. Inside 2.3, few of the videos are left that I will cover in upcoming section. Inside 2.7, we have to understand about a Restconf protocol. So for that, I have created two videos. One video will tell you that how Restconf is working, and I have given one example related to Cisco SD-WAN. And inside video number 38, you will understand how we can do the device configuration with respect to Restconf. So please go complete these two videos, and then we are completing section 2.7. Next protocol, we have Restconf. Now suppose if we understand Netconf and if we know HTTPS, then Restconf is mix of both. Now again, just to revise the things, if we go and check what is the protocol, so protocol is Netconf. What's the data model? We are going to use as Yang. Now what's the transport? So transport we may have different. In this case we have HTTPS, but we may have TLS, SSH, HTTP2, HTTPS, etc. What's the encoding method? We have XML JSON. Now if we go and draw the stack, so here in the bottom you have say data model, and then you have transport. Now this transport may be SSH, maybe HTTPS, maybe TLS. Then you have the encoding method. So encoding is nothing but your XML, your JSON. And then we have the protocol. Now the protocol we are talking at this point of time is Restconf, and it is mixture of HTTPS and Netconf. So here you can see in the diagram, Netconf Yang plus HTTPS become Restconf. Now whatever we have a study that is true at this point of time. Now if we go and compare the Restconf and Netconf, then we'll see that same thing that we are doing with the Netconf, same thing we are doing with the Restconf. Name is different, some syntax will be different obviously. What methods we have? So here you can see the list of method. We have methods, that means that will be very much that we are doing with the web browsing. So we have get, post, put, patch, delete. Now get means like running show command in Cisco devices. Post means we are creating new object. Put means you are updating the object. Patch means you are merging. Delete means obviously deleting the object. Everything with respect to object oriented programming, and then we are doing various operations. Now let me quickly show you the difference. So I have the difference in between the operations of netconf and the restconf. Clearly you can see that get is get config, post is edit, the operation is create, then operation is create, replace, merge and delete. Very much similar, and line to line we can understand that both are in parallel. Now it depends upon which particular platform is using what type of protocol. So for example, if I go and take the example of SD-WAN, I can go and log into the vManage, that is my management plane, and then I can open my API doc. Here you can see in the example that get methods related to CSR, RESTconf API, configuration native. So what this API will do, like that. I'll show you the quick example related to the vManagement API, a vManage API, how you can retrieve the data, how you can read that data, how you can run it, and you can get the output, correct? So what method that we can go and build with our RESTconf, the tools. So we have Python tool, we have Postman, we have Firefox, REST client. These are the tools we have, but you will see that most of the management plane, they have the inbuilt integration with some of the API tools, and from there also you can go and run with help of your web browser. So let me quickly go to my vManage via the web browser, and I'll show you that how you can execute certain APIs. Alright, so here you can see I have my vManage, and I can go back. I can go and do API docs, so I can reach to the API. Inside this API doc, I am very much interested to build and run one of the API related to monitoring, related to interface monitoring. So I can go here and search, say, real-time monitoring and enter face stat. Now here you can see that you have the monitoring, and if I can check any other real-time monitoring interface, get the device, and if I scroll down, you can see the model schema, and we should put the device name or device ID, and then here you have the method. So 200 means success, 400 bad request, 403 forbidden, 500. They are the few codes. Now here I have the query API. So I can use this query data service API, and I can paste here in the web browser. Although here you can see the response is 200 here, that is successful, and then you can see the headers and you can see the data value. Let me quickly run here in the web browser, and once I run here you can see the output. The nice thing about this, I can go to the header, and then I am looking for certain interface and the status of that. So I can go and filter with if. Here you can see clearly that the interface is gig 0/1 with respect to this device is up, 01 is up, 02 is up, like that. You can go and filter if you go and check the name. So you have various things like this is DC1, and this is the interface, this is the device IP. But apart from that, you have so many good information. If you're looking for RX and TX packet, you can go and check the TX, you can go and check the RX, and likewise. Okay, so you can see how easy it is to run and get the output, and because we are doing the API call, so this is very much machine to machine interaction. We are executing the API and then we are getting the result. In Fiverr 2, we have to use Restconf, and with help of Restconf, we have to do configuration related to device interface configuration, some static routing configuration, VLANs related configuration. You can see here I have created different script. You'll find that how to get some sort of output means using get type of APIs to get the output, then adding the route, seeing how many interfaces are there, getting details about the interfaces, deleting the interfaces, and finally, one lab is there, test one, where rest of other operations are listed there, such as VLAN related operation and others as well. The point being here is this, that we should understand how we can start, how we can write the program so they can do some sort of configuration. That is nothing but the post related operations. And then how we can execute and get the result. But the programming basics is important, because once we have the programming basics, then later on you can develop your own own scripts program, where you can get the MAC information, CPU information, memory information. You can do some sort of configurations as well. Okay, so these programs will become the baseline program, and you can utilize these information, these scripts, to build your own programming as per your infra as well. All right, so what I've done so far, I have connected with the VPN. I have one device, test device, where I'm going to execute all these programs. And let me quickly go and show my editor here. So I have my editor. I'm going to show you the first program. What it will do, you can see clearly importing few of the packages, then negating the certificate error. That's the line 3. Then you can see that I have my host, and where I want to use the Restconf to get these information. So host, so line number 6 and line number 9, they will go hand in hand. And inside line number 6, you can see this host IP that I have hard coded, that is in my lab. That's my management IP. You can make this as a variable, as a user input as well. So as um, more and more you want to create your programming as a generic or robust, so you don't want to hard code anything. You want to put as a user input or variable, correct? Then headers are there. So once you have the API headers, and then the username password. Why we have this username password? Because they will go and build the session. Building the session means that first of all you will log into the device, and then you will call something, correct? So we have the function defined to build the session, means my session is built. And then I have usability code, usability functions, who will get and get the output, like show IP route type of output. Once we have all these functions defined, then we can go to the main function, where we can call the required program that we want to call inside our program. And then you can print the output in the JSON format. That's the normal output. That's the output that we are getting from the API calls, correct? But that output, again, we can filter it, we can generate it in CSV or any other reporting format. It's up to us how we are taking the input, and then how we are printing the output. Okay, so this is one of the program. Will show you the result related to route. Let me quickly show you that environment. So I have the CSR router, and you can see the routes here. Some of the route that I'm showing you with the CLI output. Same thing we can go and check. So I can go and check Python exe. That's my 01 program. Get the IP route. Now it's running, and you can see that you're getting the result in some sort of JSON format. You see, the result is in JSON format, and we are getting the routing information, the route information here, correct? Now, once we have this basic script up and running, the second task we have is to add the route. Can you create some routing here? Can you go and create some static IP route type of configuration? And here you can see, again, now what will happen next time when you use this, you'll find that first few lines, so at least up to line number 1 to 18, they are the same. Okay, then we are defining the payload, what I want to configure, correct? So one of the static route, I'll go and change the parameters here. I'll make this prefix as a 30, 30, 30, 30, and then the next hop I can make as 55555555. Let me save this. So now it is saved. And if you go here to the CLI, Let me quickly go here to the CLI where I can show you that we don't have a route, a static route related to 30-30 network, correct? 30-30-30 and the next hop. Simply you can see that once we have the payload, the next of the configurations are same. I build a session, then the new function we are introducing here is the add the IP route, calling the URL, and then push via the payload, because this is the post type of operation, correct, where we are doing some configuration. And then finally, we are um, sending inside the main function, means we are calling this particular function inside the main function, and it will go and give you the result. So now if I can go here to the script and let's open both the CLIs. Here I can go and run that program as a 02, add the route, and if you go and check 30-30-30 has been added. See how easy it is, just click one script and it will work. The next small script we have related to get the interface information. Okay, again, everything is very much similar. What are the changes we have? You can see that path will change here. Path is interface. Here you can see, because this is routing related configuration. So here the path is IP route. Again, here you can see the path is IP route, because this is the get related to IP route. This is post related to IP route. This is the interface information. Almost the same. Now I can go here back and I can run that 03 program that we have. And once it is running, you can see that we are getting the interface, all the interfaces that we have information in the JSON format. Again, we have option. We can again filter out, we can again do some sort of, put some sort of condition in this, and whatever format we want to have the output, we can get the output. Okay. Then finally, in the lab, it is telling that can you go and add the interfaces. So again, here you'll need the post operation to do, correct? So you need some sort of payload. So you can see that the payload that we have, it is there in one of the YAML file. YAML file name is interfaces.yml. Okay, so from where I will take the payload, and that payload will be used inside this function called add the interface, and in the main function we'll go and add it. Okay, so let me quickly show you the payload that we have is the interfaces YAML. Instead of loopback 3, I will go and create loopback 66 and loopback 77. I'll change the IP. The IP I'll make is 66, 66, 66, 66. And here I will go and make the IP as a 77777777. Correct? Now, if you go back here and if you check the CLI, show IP into brief, you'll see that you don't have 7766 configured. Now we'll go and run our script. So I'm going here and we can run our script, that is the fourth one, add interface, and it is working. Now, if you go and check the script, you'll find that 77 and 66 has been added successfully. Okay, so these are the way that we can go and utilize these script run inside our program, and it will work as efficient as it can be. Finally, if you want to check some more information, so you have something called 05 as well. If you want to delete the interface, it's easy to delete as well. What you need to do, select that interface and use the delete operation. I have given that a script here. Then we have one big script as well related to test1.py, where this script will do plenty of operation. First of all, the functions have been defined. It's defined here. You can go and have a look. You can get the VLAN information. You can get the other informations as well. And the bottom in the main function, you'll see that whatever things you want. Suppose if you want to see the get VLAN, if you want to see the validate the Restconf, you just remove this symbols, and you will get the those details, those information. For example, if I go and remove this and save it, I'm going to show you just one output here. Oops, my VPN connection. Just going to show one output here, and if I go here to run this program, test one, and if see, so it is printing the capabilities, that whatever capabilities we have in this CSR router, the iOS image, it is telling you all those capabilities. Like that, you can explore more inside this program. The same way it will start, and then there are functions like get VLAN interface related information, VLAN related information. You will get inside this. All right, so we have completed this section. Let's just stop here. Let us learn that how we can do the Netconf basic lab setup. So in this case, how it is that I have my controller. So let me quickly draw the diagram here. So I have my controller, and this controller has the reachability with the iOS XR routers, say for example router 1 and router number 2. I'll log into the device and I'll show you the configuration as well. But we should have a reachability. Now in the controller, we have one Python program that is running nc.py, and then obviously we can go and log into the agents. So these are my agents, these XR devices, where if suppose if the netconf and yang is not installed, I should go and install first. So I'm going to show you the steps first of all, that what are required to enable the netconf and the yang. Once it is there, then we'll go and do the transaction between the controller and the devices. We'll check the hello or hello world command like that, but we'll do the basic transaction in terms of hello.xml file that we have. All right, so let me quickly go and log into the XR devices and the controller one by one, and we'll go and perform the lab. Okay, so let me go and open my devices. So here I am inside the LER device, and what we should do, that we should go and enable the SSH. Although the SSH is already enabled here, and see if I can get the key. Okay, so key has been generated. Now once key is there, I can go and give the, I should go to the global configuration mode, and we can give this SSH server as version 2 or v2. Then we can go and enable the netconf, and we have a VRF called default. Everything is inside the default VRF in our case. So the netconf yang, and this is the agent, and here I should go and enable SSH. Now I can go do commit of this configuration, and we can go and check the IP addresses that what we have here. So here you can see that one of the loopback address is 172.162.55.1. Now I want to go and do the transaction, and I have this hello file, so I can show you that. We can go and check the hello XML. So we have the capabilities related to netconf, and then we can go and run this Python program, connect with this device. We are going to do the SSH. The netconf port number is 830. We're going to go and check the hello.xml, and I don't want to sleep for 30 seconds, 60 seconds. So rather than I will go and sleep for just for 30 seconds. And then we'll go and close the session. So now here you can see that the transaction is going on. I can go and verify that the agent is there or not. So for that, I can go and check the Netconf Pyang and yep, the agent. Or we are the client, so we can go and check. Now here you can see that we have the session open, and if we go back to the controller, so here you can see that the transaction has been done successfully. Okay, so this is the way that we can go and do the transaction. Now suppose if I want to run a basic configuration command, and we have the full-fledged Python program that is running behind the scene. So let's go and do that configuration as well. All right, so let me show you the basic program that we want to run here. So for that, we have the get file, and we want to use that get file. So what this program will do behind the scene, we'll see that. So I can go to the file, and we have the getconfig.xml file. Here I want to sleep for say 15 seconds just to see the session is there or not, and then I want to close the session. So now here you can see this configuration is happening behind the scene, and I can go and check the session. The NC version showing unknown. NC version is 1.1, that is going good, and the operation is get the config. Now here we can see that the configuration is getting stored inside the rs get config. Now I can go and check the rs get config.xml, and here you can see that we have the output in the XML format. So we have this IP, we know that the loopback address is this, and then we can go and check the management IP. This is the management IP, and the rest of the configuration you can see, correct? So how easy this transaction happens, and we got the output. All right, so let's stop here. In 2.3, we have to understand different type of data types such as JSON, XML, YAML, plaintext gRPC, and Protobuf. What I've done that we already covered in previous section video, you'll find that we have covered up to JSON, XML, YAML, plaintext I'm not covering here. These topics I have already covered in previous section, and after this video you'll find video number 42 that is related to gRPC. In this section we are going to discuss about protocol buffers that is developed by Cisco as an open standard. It is a language neutral, platform neutral, extensible encoding method, and you can think this as it's a faster than XML. Why? Because mostly it is treated as a binary encoding format. So yes, like JSON, XML, this is also encoding methodology, but it is useful for all the platforms that we have. Now, if we go and compare with respect to JSON, you will find that JSON is also good, and it's a great human intelligence in terms of it's very easy to understand, read, etc. But the problem with JSON is that this is not compatible with all the different type of cross platforms. Whereas Protobuf will find that it is compatible with Python, C++ library, Java library, etc. It's like machine language to, or you can think as a service to service, not a language, but it's encoding used via protocol, so it can be used inside any language, right? The extension for this is .proto. So when we are saving this file, it is like .proto file. It also have different type of types, means it can have integers, floating numbers, string, booleans, etc. It has numbers as well. It has name as well. One syntax example, you can see how this look like. Here you can see that the example where you have this encoding proto buffer example. Right? So have a look. You can see that proto 3 package tutorial message person required a string, integer 32 ID option is string, email, enumerator, mobile home, etc. Means this is just like a encoding data format for machine to machine for fast transactions. And since this is open, since this is fast, so it is usable for vendors. At the moment, Google has developed this. So Google, they are using inside their internal servers, internal messaging, internal communication with this encoding. Next protocol, we have gRPC, Google RPC. This is the functional subset of Netconf run over HTTPS. It has high performance. It provides simple client development. And here you can see the protocol stack. Now, already we have discussed this, that we have the data model, we have the transport, we have the encoding, and then the protocol. Correct? So here you can see the encoding is JSON CLI, the transport is HTTP, data model is Yang. And now next, if we go and check that what type of methods that it has, so here you can see that the method that we have is, obviously we know that we have get, put, post, and delete. Likewise, here you can see that we have different type of methods. We have the get conf, merge conf, delete, replace, get operation, so retrieve the operational data, CLI config, merge the configuration data in CLI format, and finally, so CMD text output. Okay. So likewise, other protocols that we have, this is also will be used, and this is high performance. Again, the functional subset of netconf, and the protocol format also we have seen. All right, so let's stop here. In this section, we are going to understand about netconf data store. Here you can see the architecture view. Few of the data stores we know from our Cisco knowledge. We know that inside the routers or switches, we have a startup config, running config. Even if we go and check the XR devices, you'll find that when you write the configuration, you have to do commit. Even the devices managed via vManage in the SD-WAN world, we have different type of data stores, because there netconf, we have netconf enable, and we know that how we manage pushing configuration to edge devices. Okay, but here let's understand about the schema, a model about the netconf data store that we have. So you can see that we have the running a startup that we know already, and then we have candidate, we have intended, we have operational data stores. Now this particular diagram is quite important, because you can see here that inside operational data store, what type of data stores they have. So they are coming from the top. Apart from that, they have a dynamic configurational data stores. They have a learned configurations. They have system configurations. They have default configuration. They are in the system state. Correct. Now, if you see the intended data store, you can see that the running configuration, where you have the CT and RO. RO stand for read only, RW for read write. CT is config true, CF you will find as a config false. These are the standard taken from the RFC. All right, so actually this snapshot taken from the netconf data store RFC, and there you'll find the same diagram that we have. Now, let's continue and understand more about that. So here you can see that the intended data store, subject to validate, you have the configuration transformation and removal of inactive configuration, etc. So let's discuss one by one. all these data store. And before going there, what we want to memorize here. So when we are talking about running configuration, we know that we can do some configuration, we can commit it. So it will be there in a running. Then if you have the non-volatile memory, that's a startup configuration, you can save that to the startup, that's the copy config. Then you have the candidate, you can commit as a running. Then you have the candidate configuration, you can commit as a running, and you can save to the startup. This is the flow that generally we are following. But apart from that, let's discuss a little bit more about the operational and intended. Already I told you that operationals having these many data stores, these many configurations. All right, so we have running a candidate, a startup, intended. Okay, a startup configuration, you know that those type of configuration that you have that you need over the devices. So a startup configuration data store or a startup is a configuration data store holding the configuration loaded by the device when it boots. Okay, the startup configuration data store may not be supported by all the protocols. That's important, correct? Now at boot time, the devices load, they save the startup configuration into running. This is the flow that we can uh, memorize. Then after that, you can see that we have the candidate store. Candidate store means there you are doing uncommitted changes. Means if you commit, obviously it will commit it to the running configuration. Candidate does not typically persist across reboot. Obviously, if you reboot that, you will lose the candidate configuration. You have to do the running configuration, and then that running configuration also you want to save to the startup. That's the same flow that we know from our Cisco world. Then we have our running configuration. Running configuration must always be a valid configuration data tree. Running configuration must be supported if the devices can be configured via the conventional configuration data store, like we have the running, candidate, and a startup. And then with the copy command, we are saving our running configuration to the NVRAM. Correct? That's our startup configuration. Correct? Where you have config to and read write. Great. Now, then we have something called dynamic configuration. So nowadays, what is happening that we are in the world where we are creating a small templates, and those templates are become the part of main device configuration template. Okay, so you may have some dynamic configuration that in future will become the part of the configuration that may fall under the dynamic configuration data store. Obviously, it can lose upon reboot, but if you have some orchestrator where you can put those configuration, they are not in use, but still they are somewhere in the orchestrator, so it will be saved. Otherwise, they can lost upon the reboot because they are the ephemeral configurations, correct? Then operational, that I already told you. Operation does not persist across reboots. I told you that operational means that you have your valid configuration and then plus learned configuration, plus system configuration, plus default configuration. There's a system state. The system state itself will show you that it is in the operational mode or it's the operational. Okay, so these are the explanation related to Netconf data store. Have a look on these notes that I have created. Okay, and you will get the clear idea about the data stores. Behind the scene, we are using these data stores, but theoretically also we should know that these many data stores we have inside Netconf.